Hello there and welcome to Just About Earth, a quiet corner for anyone who likes to settle in, soften their thoughts, and wander gently through the stories of our world. Tonight, we're taking a slow walk through something deeply human, something shaped over millions of years and yet strangely stalled in our present moment. It's a question that sits right at the intersection of curiosity and comfort, the kind of thought that drifts into your mind when the day is winding down and everything feels just still enough to wonder about where we came from and where we're heading. We're asking why human evolution, this long winding process that shaped us bone by bone and thought by thought, seems to have slowed, hesitated, maybe even reached a quiet sort of dead end. Not a dramatic halt, not an extinction cliff, but a pause so intriguing that it invites us to look closer at ourselves. Before we ease into that journey, I'd really love to know where you're listening from tonight. Somewhere warm and familiar perhaps, or somewhere chilly where the blankets feel extra welcoming. And what time is it for you right now in your part of the world? It's funny how a question like that can instantly make things feel smaller and more connected, even when we're separated by time zones and half of the planet. Here we are, sharing this moment, drifting through an idea together while our clocks quietly mark the hours in their own ways. If this little expedition feels soothing or interesting, or just a nice way to unwind after whatever your day has been, I'd be grateful if you gave the video a like or maybe subscribed. It helps this calm corner find others who might need a slow, thoughtful space as well, and it lets us keep wandering through questions like this one. Now, the thought of human evolution hitting a dead end might sound heavy at first glance, but you don't need to brace yourself. We're not here to sound alarms or spin dramatic tales of collapse. Instead, we're simply taking a closer look at how evolution really works, how it moulded us into the beings we are, and what changed in our world to slow that process down. It's a quiet kind of mystery, more about understanding than urgency, more about curiosity than concern. The story of our species is full of turning points, stretches where change happened quickly, and long plateaus where it almost disappeared. And right now we happen to be standing on one of those plateaus wondering what comes next. When we think about evolution, we often imagine an ongoing climb, a steady march forward, each generation nudging the next towards something sharper, stronger, faster, or more resilient. But real evolution doesn't follow a tidy line. It wanders, it experiments, it leaps suddenly and then waits. Sometimes it races ahead for reasons we can see, and sometimes it slows for reasons that hide beneath layers of culture, technology, and comfort. Humans in particular have shaped their environments so thoroughly that many of the pressures that once guided our development simply aren't as forceful anymore. Our ancestors lived in worlds where survival framed every choice. Our world looks different, feels different, and asks different things of us. So here we are, a species once sculpted by struggle, now cushioned by inventions that buffer our weaknesses and amplify our strengths. That shift alone could explain why the process that once carved us into what we are has started to lose its urgency. But that's only one part of the story. There are many others woven into this question, each one worth lingering on, each one revealing something subtle about ourselves. The moment we start looking at how evolution typically operates in other species, we begin to see that our relationship with it isn't so standard anymore. It changed as we built shelters, shared knowledge, formed communities, developed tools, and eventually reshaped the entire planet to fit our needs. When a species becomes the author of its own environment, the rules that shaped it begin to bend. As we wander deeper into this story, it becomes clear that human evolution didn't stop because something went wrong. It slowed because we became uniquely good at controlling the world around us. We don't rely on raw physical adaptation the way other animals do. Instead, we adapt through ideas, through inventions, through social bonds that protect even the most vulnerable among us. That shift changes everything. It raises questions about what it means for a species to evolve, when its survival is no longer determined by the kinds of pressures that shaped it in the first place. Once upon a time, we were shaped by danger, scarcity, climate, and competition. Today, we are shaped by culture, technology, and choices that reach far beyond biological inheritance. But that doesn't mean our story is finished, not at all. It simply means the forces guiding us have changed. Instead of natural selection pressing in from every direction, we now see other influences nudging us slowly, indirectly, sometimes in ways we barely notice. The things we choose to value, the ways we communicate, the lifestyles we adopt, even the foods we eat and the places we live, all of these create new patterns that shape the generations that follow. They might not look like the pressures that guided early humans, but they do carry weight, just in quieter, more complicated ways. And maybe that's why this topic is so compelling. It invites us to explore not just how evolution works, but how our relationship with it has shifted since we began building cities, farming land, and forming societies that shelter everyone regardless of their natural strengths. When every individual is protected, cared for, and supported by others, the direct pressures of survival look different. Instead of a world where only the physically strongest or most adaptable survive, we live in one where cooperation and knowledge allow all kinds of people to thrive. That changes the evolutionary landscape dramatically, and not in a way that spells doom. It simply means the path is no longer linear. While we explore this, it helps to keep in mind that humans haven't stopped changing entirely. Our genes still shift across generations, mutations still happen, some traits spread, others fade. But the pace of meaningful biological evolution is slower now, diluted by the sheer size and interconnectedness of our population. Our ancestors lived in smaller groups that changed rapidly due to isolation and selective pressures. Today, billions of people share their genes across continents, reducing the chances of a small group diverging genetically in a big way. It's not that change is impossible, it's just less directional and more diffuse, drifting rather than marching. All of this paints a different picture than the one we often imagine when we think of evolution. Instead of a dramatic halt, it's more like a vast, calm field where the forces that once whipped around us have grown gentler, quieter, more subtle. They still exist, but they shape us slowly now, almost imperceptibly. That's part of why scientists sometimes refer to our current state as an evolutionary pause or plateau. Not a dead end in the dramatic sense, but certainly a moment where the old rules have softened. And so, we arrive at the heart of the question, not with panic or urgency, but with curiosity. Why has the grand process that shaped humanity slowed down? How did we reach this place where biological evolution seems less critical than cultural and technological evolution? And what does it mean for our future, both near and distant? These aren't questions with quick answers, but they're questions worth sitting with as the night grows quieter and the mind starts drifting into deeper thoughts. When we start looking at the long arc of humanity, something becomes immediately clear. Our species has gone through periods where the pace of change was breathtaking, where every shift in climate or food source or landform reshaped us in ways you can still see in your face, your hands, your heartbeat. For millions of years, evolution was not some quiet backdrop. It was an ongoing negotiation between our biology and the world pressing in on us. Every generation carried the markers of what worked, what didn't, and what barely scraped by. But at some point along the way, that rapid shifting began to calm. The landscape softened, not in its physical terrain, but in how strongly it pushed against our survival. And as those pressures faded, so did the need for constant biological reshaping. That's where the slowing begins, not with a sudden stop, but with a steady easing, the kind you barely notice until you stand back and compare distant points on the timeline. Imagine our ancestors moving across shifting plains, forests and coasts, where every day was shaped by immediate demands. They had to find food without knowing what the next hour would bring. They had to avoid predators, withstand harsh cold or sudden heat, and adjust to changes in their surroundings faster than we scroll through a menu on our phones. In those conditions, small adjustments mattered. A slightly better way of gripping, a more efficient stride, a more perceptive eye, a stronger immune response, even a bit more social cooperation could mean the difference between raising children or leaving no trace at all. Evolution noticed every one of those adjustments. It rewarded anything that kept a person alive long enough to pass on their traits. It wasn't personal. It was simply what happened when life met environment with no mediating force in between. But as humans grew more capable, the environment stopped being such a relentless sculptor. We began shaping the world faster than it shaped us. The moment we developed reliable tools, hunting strategies, shared knowledge, and coordinated group behaviour, something shifted. Our survival no longer depended solely on the quickest or the strongest, or the most naturally resilient. It depended on cooperation, communication, and creativity. Those strengths are powerful, but they don't leave the same kind of evolutionary fingerprints that physical pressures do. When a group protects its members, evolution loses some of its harsher leverage. The frail, the injured, the very young and the very old all survive more often. That survival matters because evolution operates through differential survival. When almost everyone makes it, the range of traits that continue becomes broader, softer, no longer funneled tightly toward specific outcomes. Once early humans created stable shelters, the need for extreme cold resistance dropped. Once fire became a daily tool, digestion changed because cooking meant calories arrived more reliably and in a gentler form. Once social networks grew complex, individuals didn't have to rely entirely on their own physical advantages. A person's value came from many traits beyond body strength or raw instincts. Knowledge, memory, humour, teaching, and even the ability to stay calm under pressure became central to group survival. Many of those qualities are influenced by a blend of biology and experience, but they don't operate through the same cut-and-dry selection we see in other animals. The more interconnected people became, the more insulated they were from solitary natural pressures. That insulation didn't freeze evolution entirely, it simply changed the pace and direction. Over time, this shift created an unusual situation. Humans were still evolving, mutations still arose, natural selection still operated. But the selective pressures acting on us weren't as clear or consistent as before. In earlier eras, the environment dictated everything. If food sources changed, bodies changed. If predators threatened, behaviours changed. If climates shifted, limbs, lungs, and metabolism adapted. But with the development of tools, agriculture, shared labour, long-distance trade, and eventually entire civilizations, our survival story stopped being tied narrowly to genetics. Skill, cooperation, planning, and cultural systems took over many of the roles once played by biological traits. That kind of shift doesn't halt evolution. Instead, it makes the direction of change less predictable. Evolutionary pressure thrives on consistency. When an entire species experiences similar challenges, the solution spreads quickly. But when a species creates its own environment, and that environment differs wildly across the globe, the pressures become scattered and diluted. Some communities thrive in warmth, others thrive in cold, others live at high altitudes, low altitudes, islands, plains, forests and deserts. Each place exerts its own subtle influence, but the world no longer pushes the species in a unified direction. We blend traits across continents, cultures and lifestyles, mixing genetic variations that once would have remained isolated. Instead of narrow funnels shaping our development, we get wide, intricate networks. This shift becomes even clearer when we look at how human population growth affects evolutionary pace. When populations are small, genetic changes spread quickly. If a beneficial mutation appears in a group of a few thousand, it can take hold and reshape the population within a relatively short span. But when you have billions of individuals, that same mutation is just a drop in an ocean, It might help, it might matter, but it's one voice in a massive crowd. Evolution can still act, but the scale slows everything down. It's like pouring dye into a thimble versus pouring dye into a lake. The effect takes much longer to notice in the larger volume. As societies expanded and trade-connected far-reaching populations, the blending of genetic lines made rapid divergence even less likely. Evolution relies not only on mutation but also on isolation. When a group is separated, it adapts to its own conditions, often developing unique traits over time. That's how many species form. But humans, instead of drifting apart, kept travelling back toward each other. Migration patterns, trade routes, shared cultures, and eventually global transportation allowed traits to intermingle constantly. Instead of splitting into sharply different paths, humans took the opposite approach. We merged our paths. That merging slowed the pace of biological distinction further. This doesn't mean evolution isn't happening. It simply means its tempo has shifted from a steady beat to a faint hum, woven into our lives so subtly that we rarely notice it. Today, instead of facing constant physical threats, we face challenges of a different nature. Some of them might influence evolution very slowly over time, but they're not the immediate life or death pressures that defined early human history. Modern challenges often influence behaviour and culture far more than biology. For instance, access to healthcare reshapes who survives and for how long, but it doesn't necessarily select for inherent biological resistance in the same way pre-modern environments did. Similarly, food availability is shaped by agriculture and distribution, not by individual hunting skill or digestive adaptation. This shift becomes even more interesting when we consider how our intelligence changes the relationship between environment and biology. Intelligence gives humans something rare in evolution: the ability to respond to challenges through innovation instead of mutation. When the climate cools, we build warmer shelters rather than growing thicker fur. When food becomes scarce, we plant crops or store resources rather than developing new digestive systems. When diseases spread, we pursue treatments instead of depending solely on natural resistance. Innovation bypasses many of the selective filters that would otherwise force our biology to adapt. Every time humanity solves a problem with knowledge, tools, or cooperation, evolution has a little less work to do. Some people wonder whether this means humans have reached their final form. But evolution is not a ladder or a sequence of upgrades. It's a process that responds to pressures. When the pressures change, the process changes. When pressures ease, evolution becomes quiet. And when pressures shift from physical to cultural, evolution follows a different tempo. Humans didn't cease evolving. We simply moved into an era where our own inventions shape our lives more strongly than our genes do. Cultures change faster than DNA, and so the parts of us that shift quickly are no longer biological but social and technological. That difference creates the impression that biological evolution has paused. To understand why this slowing feels so pronounced, it helps to look at the traits that once defined our progress. Early in human history, changes in brain size, hand dexterity, limb proportions, and vocal structures had enormous impact. Those shifts were visible, measurable, and tied directly to survival. But once humans reached a threshold where our brains were capable of complex reasoning, language, planning, creativity, and teaching, the advantage gained from further biological adjustments wasn't as clear. Evolution tends to stop refining a trait once it reaches a point of diminishing returns. Our brains are remarkable, but they're also costly. They use a large portion of our energy, require long childhood development, and introduce vulnerabilities during birth. Increasing brain size further could introduce more problems than benefits, so that trait stabilized, at least for the time being. Similar stabilization happened with other features. Our hands are dexterous enough to create tools of incredible precision, from stone flakes to microchips. Our bodies can travel long distances, carry weight, withstand a wide range of climates, and maintain endurance unmatched by many mammals. Once a trait reaches the point where additional refinement offers little survival benefit, evolution often shifts its attention elsewhere. When you add cultural and technological innovation to the mix, the need for further biological refinement becomes even less pressing. So the slowing of evolution doesn't point to failure or stagnation, it points to sufficiency. Humans became versatile enough to thrive in countless environments without needing radical new biological adaptations every few thousand years. Once versatility becomes a species' main strategy, rapid physical evolution becomes less necessary. That shift creates a broad plateau, a period where change happens but at a pace so slow and diffuse that it's easy to mistake it for inactivity. And yet, even as the biological pace quiets down, the story continues. Cultural changes build on themselves. Technologies alter the conditions of life. Choices, values, and social structures influence who thrives and how communities function. Those forces, though not purely biological, do shape the conditions future generations experience. They create new patterns that might influence evolution in subtle ways over very long periods. Nothing is fixed in place. The process simply isn't operating in the same mode it once did. When we look back at the long sweep of human history, there's a moment that stands out so sharply that it still shapes our lives in ways we often take for granted. It wasn't a single discovery or a dramatic event recorded in some ancient carving. It was a gradual transformation that built on countless earlier steps, each one small on its own, but together forming a shift so significant that everything following it grew from that foundation. The last major biological leap our ancestors took wasn't about suddenly becoming smarter or growing new limbs or waking up one morning with a fully formed ability that hadn't existed the day before. It was the culmination of changes that allowed our lineage to move from surviving the world to actively reshaping it. The story begins long before anyone looked remotely human. Our distant relatives, scattered across landscapes that were unpredictable and often unforgiving, carried traits shaped by millions of years of selection. They didn't know they were building toward anything, they simply endured. But as time passed, certain patterns emerged, and one of the clearest patterns was the increasing importance of cooperation. While many species competed constantly, early humans leaned into the opposite direction. Working together wasn't just convenient, it was necessary. Herd predators were stronger and faster. Natural disasters struck without warning. Food sources moved or vanished. Yet these early communities survived because they pooled knowledge, shared tasks, and protected one another. This cooperative pressure set the stage for something deeper. As groups depended more heavily on shared strategies, the value of communication rose. It wasn't enough to gesture or mimic. Reliable signals were needed. Those signals could start simple: warning calls, shared attention toward danger, certain movements that indicated food, safety, or threat. But the more these signals mattered, the more selective pressures nudged our ancestors toward better ways of sending and receiving information. Communication didn't leap from silence to full language. It expanded step by step, and each improvement gave groups an advantage. Those advantages over thousands of generations added up. But communication wasn't the only factor contributing to the last major leap. Mobility and diet played enormous roles. When early humans adopted bipedal walking as their primary style of movement, something subtle but influential happened. Freeing the hands wasn't simply a neat party trick. It opened possibilities that reverberated through every part of our development. Hands that could carry food over distances, cradle children while moving, or shape tools became assets unlike anything most animals possessed. Bipedalism also changed the structure of the pelvis and spine, which influenced childbirth and brain development. Every adjustment connected to another, and over time the entire architecture of the species shifted to support these advantages. As hands became more involved in manipulating the environment, tool use followed. What began as simple stones or sticks gradually became more deliberate. A stone with a sharper edge, formed intentionally, allowed early humans to access types of food no other species could reach so easily. Bone marrow, tough roots, thick hides, and durable nuts became accessible. With each improvement in toolmaking, survival became easier, and with easier survival came another change: more energy available for the brain. Brains are expensive organs. They demand a significant portion of the body's daily energy budget. Early mammals couldn't afford large brains without sacrificing other survival traits. But humans found ways to increase the available calories. Cooking, though likely a later development, amplified this change further. Cooked food is easier to chew, easier to digest, and offers more energy. These dietary shifts fueled larger, more complex brains over time. Again, no single generation woke up dramatically different from the last. These changes were incremental, subtle, and often invisible to the individuals experiencing them. Yet the cumulative effect built toward one of the most significant transitions in human evolution. Eventually, our ancestors reached a point where their cognitive abilities allowed them to hold ideas beyond immediate surroundings. They could remember complex patterns, anticipate seasonal changes, track the habits of prey, and navigate social relationships that grew increasingly intricate. Social structure became a major part of survival. Understanding alliances, recognizing obligations, maintaining trust, and resolving conflict required more than instinct. It required layers of thought that could juggle multiple possibilities, interpret intentions, and adjust behavior accordingly. This level of social intelligence was one of the milestone steps feeding into the last major leap. As these capabilities grew, something else emerged: symbolic thinking. This was a quiet shift, but it marked a threshold unlike anything before it. Symbolic thinking means being able to represent something that isn't physically present. A gesture, a mark, a sound, or an object could stand for something else entirely. Once a group could understand those representations, communication expanded exponentially. A warning didn't require seeing a predator. A signal didn't require pointing at food. A shared memory didn't require experiencing it at the same moment. The world of ideas was no longer tied strictly to immediate perception. This opened a doorway to storytelling. As stories circulated within groups, information lasted longer than any single lifetime. Knowledge could accumulate, be corrected, expanded, and transmitted. Instead of evolution relying solely on genetic changes, culture began providing a parallel system for adaptation. A community that could teach its young how to craft tools, recognize dangers, understand seasonal cycles, and navigate social expectations didn't depend on biological instincts alone. It depended on shared intelligence. This marks the point where the last great leap becomes unmistakably clear. The transition from instinct-driven survival to knowledge-driven survival marks one of the most defining shifts in human evolution. The species wasn't merely responding to the environment anymore. It was planning around it, predicting it, preparing for it. That shift in cognition, communication, and cultural transmission built the framework that allowed humans to thrive across every continent. During this period, the rapid development of language likely played a central role. Language doesn't have to be as complex as what we use today to be transformative. Even rudimentary structured communication allowed early humans to coordinate hunts, share resources, pass along important knowledge, and strengthen social bonds. Language doesn't fossilize, so tracing its exact timeline isn't easy. But what we can see in archaeological evidence is that the complexity of human behavior grew dramatically once symbolic capabilities were in place. Art provides one of the most compelling examples. The creation of early carvings, pigments, engraved objects, and eventually cave paintings demonstrates an ability to convey meaning beyond immediate function. These creations weren't just decorations. They were records, expressions, instructions, or reminders. They reveal minds capable of abstraction but grounded in practical reality. These creations indicate a leap in cognition that signalled the species had crossed into territory no other species had reached at that scale. Alongside mental growth came changes in social depth. Larger communities required coordination. Cooperation wasn't just optional, it was crucial. With that came an increasing need for empathy, fairness, and conflict management. Groups that could manage internal disputes, distribute tasks, and care for vulnerable members had higher survival rates. The development of moral instincts, though not framed the way we understand them today, likely emerged during this period. The species needed mechanisms to maintain cohesion. Those mechanisms became part of the foundation we still rely on. Another aspect of this leap involved long-term planning. Humans began preparing for future seasons, storing food, maintaining shelters, and understanding migration patterns. When a species can plan across months or years, it changes the entire arc of survival. Planning reduces immediate pressures, stabilizes community life, and allows for the development of specialized roles. When some individuals focus on toolmaking, others on hunting, others on gathering, others on caretaking, the efficiency of the group increases. That diversification again amplifies the role of culture, further reducing reliance on biological selection. By this point, human evolution was already shifting into a new mode. Biological changes continued, but cultural changes began outpacing them. Innovations could arise in a single generation and benefit the entire group immediately. Compare that to biological evolution, which requires countless generations for a significant change to spread widely. Once culture became the dominant adaptation strategy, the need for rapid biological evolution decreased. Still, some biological changes did occur in this period, and they were significant enough to leave lasting marks. The anatomy of the human throat and mouth shifted in ways that allowed for a greater range of vocal sounds. This required changes in the skull, neck, and respiratory structures. These adjustments weren't without risk. A lower larynx increases the chance of choking, yet the advantage offered by enhanced communication outweighed this drawback. Natural selection favoured improved vocal flexibility because social coordination offered survival benefits that overshadowed the risks. Brain structure also changed. The prefrontal cortex, crucial for decision-making, impulse control, and social understanding, became more sophisticated. Neural pathways associated with memory, planning, and creativity strengthened. These weren't superficial adjustments. They altered how individuals perceived challenges and opportunities. With improved cognition came the ability to innovate more rapidly, experiment with new ideas, and refine old strategies. Another change involved emotional regulation. Living in larger groups requires a degree of stability and interpersonal behaviour. Overly aggressive individuals risked exile or punishment. Those unable to cooperate faced challenges. As a result, tendencies supporting patience, cooperation, and shared responsibility found their place in the species over long stretches of time. These emotional capacities helped stabilize group structures and provided another layer of support for cultural growth. Reproductive patterns also shifted. As communities became more stable and shared resources effectively, raising children became less about immediate survival and more about long-term investment. Infants, with their long dependency period, could thrive when supported by multiple caregivers. This cooperative child rearing allowed for extended learning periods, which in turn allowed knowledge to accumulate and pass through generations with increasing complexity. When we look at all these developments together, the last major evolutionary leap comes into sharper focus. It wasn't one feature, it wasn't one discovery. It was the transition into a species capable of shaping its own destiny through knowledge, cooperation, communication, and planning rather than relying solely on genetic changes. That transition laid the groundwork for everything humans later achieved. It created the conditions under which evolution began to slow, because survival no longer depended entirely on biological traits. Culture had taken the lead. Yet even as this leap brought remarkable capabilities, it also carried consequences we still navigate. The same intelligence that allowed humans to thrive brought complexities that earlier ancestors never faced. Social structures grew intricate, responsibilities expanded, tools became more advanced, communication became more layered. The world stopped being a simple negotiation with nature and became an ongoing negotiation with one another. This shift didn't halt evolution, it redirected it, setting the stage for the slowdown we explored earlier. For a moment, imagine setting aside everything you normally associate with human intelligence. Not the inventions, not the sciences, not the achievements stacked across history. Instead, picture the simplest sign of a developing mind. The ability to notice something, consider it, and hold that thought long enough to decide what to do next. This ability may seem ordinary now, but in the long timeline of evolution, it marked a turning point that changed the direction of our species. The human brain, long before it produced writing or mathematics or technology, started expanding in a way that offered both remarkable advantages and complicated consequences. This expansion became so influential that it reshaped the entire structure of human life, and in doing so, it created a situation where evolution no longer had the same room to guide us as it once did. Our ancestors didn't plan for this expansion. They didn't look around and think, a larger brain would really help us out. Biological change doesn't work like that. But as their environment demanded more flexibility than instinct alone could provide, the individuals capable of noticing patterns or learning slightly faster often fared better. A mind that could remember where food was found last season, or which plants caused harm, or how predators behaved gained an advantage even when physical traits remained unchanged. The brain became a tool of increasing importance, and selection pressures rewarded those who could use it in more efficient ways. Over many generations, that growing reliance on mental adaptability pushed the brain into a rapid phase of development. In earlier ancestors, this process began slowly, but as tool use, social cooperation, and communication deepened in complexity, the benefits of enhanced cognition multiplied. A feedback loop formed. Better thinking led to better tools supported survival, survival allowed for further brain growth, and the cycle continued. Yet this cycle created an unexpected complication. Large brains require enormous energy. They need long developmental periods. They demand extended caregiving. They introduce vulnerabilities that other species simply don't have to manage. And still, humans invested in this direction because the advantages outweighed the costs. What followed was an organ so capable that it eventually overtook its own original purpose. The brain wasn't just solving problems of survival anymore, it was solving problems it created. With every new idea, humans altered their environment, which then required new solutions. This self-reinforcing pattern continued until the role of biological evolution shifted dramatically. Instead of shaping minds to fit the world, minds began reshaping the world to fit themselves. That reversal is one of the defining reasons evolution slowed. When a species can modify its surroundings at will, natural selection loses the leverage it once held. The human brain, in its expanding capability, crossed a threshold. Beyond that point, it could invent tools that compensated for physical limitations, create shelters that protected from harsh climates, and develop social systems that allowed groups of individuals to survive despite vulnerabilities that would have been fatal in earlier eras. Strength mattered less, speed mattered less, even some forms of disease resistance mattered less. The brain began handling challenges through creativity, cooperation, and later through technology. When an organ becomes this influential, it shifts the entire balance of evolutionary forces. But the expansion wasn't uniform. Different regions of the brain developed along distinct paths, each supporting increasingly sophisticated forms of thought. The prefrontal cortex, responsible for planning and decision-making, grew especially important. This region allowed early humans not only to react to situations, but to prepare for them long in advance. Planning provided enormous survival advantages, making it possible to store food, coordinate group activities, anticipate migrations of prey, and avoid predictable hazards. The ability to think beyond the present moment is something we take for granted now, but in evolutionary terms, it was extraordinary. Few species operate with that level of foresight. With greater planning came greater social complexity. Humans lived in groups that relied on cooperation, and cooperation required understanding not only one's own needs, but the needs and intentions of others. Social awareness became an essential part of survival. Individuals who understood group dynamics tended to navigate conflicts more efficiently, negotiate alliances, and maintain supportive relationships. Over time, this encouraged brain structures associated with empathy, memory, and emotional regulation to develop in ways not seen in earlier ancestors. Social intelligence became just as important as physical endurance or hunting skill. Discussion of the brain's growth often focuses on intelligence in the academic sense, but the reality is much broader. The last major cognitive expansion wasn't about increasing the brain's ability to calculate or analyze. It was about broadening its adaptability. This adaptability came with a trade-off. A larger brain meant longer childhoods, slower reproduction, and a much greater dependency on community support. Infants with developing brains could not survive without consistent care. This created an extended learning period that allowed young individuals to absorb cultural knowledge, but it also required adults to invest enormous time and resources in raising the next generation. This investment, however, created tight social bonds and allowed skills to accumulate more effectively over time. The brain's development also introduced risks. A larger brain required a larger skull, and a larger skull complicated childbirth. Evolution responded by adjusting pelvic structures and encouraging earlier births, which meant human infants arrived underdeveloped compared to other mammals. This made them even more dependent on caregivers, but also allowed the brain to continue growing outside the womb. The result was an organ that could become far more complex than one fully developed before birth. Postnatal brain development allowed environmental influences and cultural learning to play larger roles in shaping the mind. As the human brain grew in capability, it became clear that its strengths extended far beyond immediate survival. It could imagine things that did not exist. It could conceptualize futures that had not happened. It could create systems of belief, navigate complicated social networks, and form long-term goals. These abilities introduced new layers of meaning and motivation into daily life. Early humans began altering landscapes deliberately, modifying tools in increasingly advanced ways, and building shelters that reflected foresight rather than instinct. This shift marked a departure from the evolutionary strategies of other species. But this increasing sophistication came with complications. A brain capable of imagining hypothetical scenarios was also capable of worrying about them. The same reasoning ability that allowed humans to avoid danger also allowed them to anticipate dangers that might never materialize. The capacity for reflection created new emotional experiences: anxiety, uncertainty, guilt, and long-term regret that had no equivalents in simpler species. These emotions, though difficult, played roles in social cohesion and cautious decision-making. They reinforced cooperative behavior by encouraging individuals to consider the consequences of their actions on the group. Eventually, the brain became the primary driver of human survival rather than the body. This shift created a divide between biological evolution and cultural evolution. Biological evolution responds slowly to environmental pressures, while cultural evolution can change in a single generation. Once humans relied more on knowledge than on genetic adaptation, the pace of change in culture outstripped the pace of change in biology. The brain, by enabling this rapid cultural transformation, became responsible for the slowing of traditional evolutionary processes. Cultural solutions replaced biological ones so effectively that the need for many genetic adaptations simply faded. There were also limits to how much the brain could expand without compromising other functions. Larger brains raise metabolic demands, require longer developmental periods, and impose structural challenges on childbirth. At some point, natural selection reached a balance where further increases in size offered diminishing returns. Instead of continuing to grow physically, the brain began optimizing its internal organization. Neural networks became more efficient, synaptic connections diversified, memory storage improved. But these changes were subtle compared to the dramatic expansion that occurred earlier. The most striking aspect of the brain's development is how it allowed humans to operate outside of strict biological constraints. When food scarcity threatened survival, humans found ways to store and distribute food. When predators posed danger, humans created tools and defenses. When climates shifted, humans built clothing and homes. These actions bypassed the slow mechanisms of evolution entirely. A species that can adjust its environment as quickly as humans can doesn't face the same pressures that drive rapid biological change. This doesn't mean the brain halted evolution, it redirected it. Instead of survival determining who passed on their genes, survival began to depend more heavily on cultural learning, social bonds and shared innovations. If we look at human evolution from this perspective, the brain's expansion did not simply provide a new set of abilities, it altered the rules under which evolution operated. A species no longer shaped entirely by nature, but increasingly by its own knowledge creates a unique situation. Evolutionary forces still apply, but they are overshadowed by cultural forces that dominate daily life. A tool can solve a problem more quickly than a mutation. A shared idea can protect a community from threats long before natural selection can respond. This made biological evolution less central to our story. Still, the brain's expansion introduced challenges that continued to influence development. Balancing social expectations, navigating relationships, and integrating into complex communities required emotional stability and cognitive flexibility. Individuals who struggled with these demands could still survive physically, but social friction could impact their ability to benefit from group life. In this sense, emotional intelligence and cooperation continued shaping genetic tendencies slowly over time. But these influences were subtle compared to the dramatic shifts seen earlier. The brain's influence also created pressures that worked against further biological refinement. For instance, with improved problem-solving abilities came a tendency to rely on tools rather than physical abilities. Humans no longer needed thicker fur, sharper claws, or faster reflexes. Tools compensated for physical shortcomings so effectively that the body no longer evolved towards specialized traits. In a sense, the brain's abilities exceeded the need for further physical adaptation, leaving evolution with fewer urgent challenges to address. With such an influential organ at the center of human life, it's not surprising that the species eventually reached a point where further biological leaps became less likely. The brain didn't stop evolution, it made additional major leaps unnecessary for survival in the same way that earlier pressures required. Once a species can plan for danger, communicate complex ideas, and create protective systems, the environment no longer shapes it with the same intensity. Instead of responding to natural challenges, the species responds to challenges of its own making, most of which unfold culturally rather than genetically. This shift does not mean the brain reached perfection. It simply reached a level of capability that removed the need for rapid evolutionary change. The brain's abilities were sufficient to ensure survival across a wide range of environments, and the challenges that remained were addressed through learning and culture rather than biological adaptation. That sufficiency is what created the sense of an evolutionary slowing. Once a species can handle most threats cognitively, natural selection begins to lose its urgency. Even now, the brain continues shaping human life in ways evolution never anticipated. It drives innovation that transforms societies faster than genes can respond. It forms beliefs that influence behavior on massive scales. It builds systems that protect millions while also creating complexities earlier humans could not have imagined. Yet despite all these effects, the brain remains tethered to the biological framework that built it. It uses ancient structures to perform modern tasks, navigating a world its earliest versions were never designed to comprehend. Long before cities rose, before farms shaped landscapes, before tools reached a level of refinement that made survival less punishing, human bodies were formed through pressures very few people alive today will ever experience firsthand. Everything about the way our muscles attach to our bones, the way our lungs expand, the way our metabolism handles scarcity, the way our joints absorb strain, all of it reflects a world radically different from the one we now inhabit. If someone were to look only at modern lifestyles, how we sit, how we eat, how we work, how we move, they might never guess that our bodies were once built for constant travel, for hunting that required endurance instead of speed, for unpredictable food sources, for dangerous predators, for climates that shifted without warning. But every part of the body carries hints of that older world. Those hints reveal how thoroughly evolution shaped us for conditions that disappeared when culture and technology stepped in to change the rules. Consider for a moment what a typical day might have required from early humans. They rarely stayed still. Food wasn't stored in cabinets or purchased from markets. It was sought in bushes, under rocks, across long distances, or gathered from trees that did not grow in predictable places. Movement wasn't a choice. It was an unbroken necessity. Bodies adapted to this reality through traits that supported persistence. Humans are surprisingly effective endurance walkers and runners. While many animals can sprint faster, very few can maintain a steady pace across the span of hours with the kind of efficiency humans possess. Our Achilles tendons, our arched feet, our sweat glands, and even our ability to stabilize our heads while running all come from a world that demanded long, steady motion. Yet most people now spend much of their lives sitting. The abilities that shape the human skeleton were not designed for long periods of stillness. The mismatch doesn't stop with movement. Early humans lived in constant negotiation with hunger. Food scarcity was not an occasional inconvenience but a recurring reality. Bodies adapted by storing energy efficiently, regulating blood sugar in ways that prevented sudden crashes, and developing fat reserves that could sustain survival when meals were unpredictable. The instincts that make high-calorie foods appealing are not flaws. They are echoes of a world where refusing extra calories meant risking survival later. But in a context where food is readily available, heavily concentrated and easily consumed with little expenditure of energy, those same instincts don't align with the environment anymore. The body is still operating on rules that once made perfect sense, but now contribute to issues that our ancestors wouldn't have encountered. Temperature control followed similar patterns. Humans evolved to survive without manufactured warmth. Fire helped, but it didn't eliminate exposure. Nights grew cold, seasons shifted, rainstorms left communities soaked, wind chilled skin without warning. To survive this, humans developed behaviours and bodies that tolerated variation. Sweat glands allowed cooling without panting. Hair patterns provided limited warmth without obstructing motion. Fat distribution helped with insulation in some climates. But now, in an era where indoor temperature can be changed with the turn of a dial, much of this natural capacity operates in a world that doesn't require its adaptive strengths. Climate control has made physical adaptation to weather less necessary, altering the relationship between the body and its surroundings in a way evolution could not have predicted. Even our skeletal structure carries signs of a world filled with daily strain. Bones strengthen when stressed consistently. Early humans walked, climbed, dug, carried, and hunted. Their bones responded by becoming denser and more resistant to fractures. Today, bone density patterns differ dramatically because bodies are not challenged in the same way. Lightweight routines and limited physical strain change how bones maintain themselves. The systems are still present, still capable, but they operate in a context that doesn't demand what they were built to handle. The digestive system also provides a clear example. Early humans consumed a varied and labour-intensive diet. Food required chewing through fibres, processing tough materials, and handling meals spaced irregularly throughout the day. The gut prepared for unpredictability. It managed microbes, tolerated imperfections, and extracted nutrients from a wide range of plants and animals. In contrast, modern diets often rely on processed foods that require little effort to chew or digest. Sugars and refined carbohydrates appear more frequently than they ever would have in the natural environments of our ancestors. The digestive system wasn't built for constant abundance or uniform textures. It responds to this new reality with sensitivities, imbalances, and reactions that simply weren't part of the ancestral experience. Another area where the mismatch becomes evident is in sleep. Sleep patterns evolved in environments where darkness dictated rest and daylight dictated activity. There were no screens, no artificial lights, no buzzing devices interrupting the night. Sleep aligned with the rising and setting of the sun, influenced by safety concerns and group dynamics. Today, most people sleep based on schedules unrelated to natural cycles. Artificial light extends wakefulness far beyond what the body initially evolved to handle. As a result, sleep systems that once functioned smoothly now struggle to adapt to constant stimulation and irregular patterns. Difficulty sleeping isn't a failure of modern humans. It's a sign that the body is attempting to follow ancient programming in a world filled with competing signals. Pain management also reveals the mismatch. Early humans needed quick responses to injury. Pain signaled danger, encouraged caution, and prevented further harm. But in a world where many individuals spend long hours sitting, write frequently, stare at screens, or move in repetitive ways that strain the body without the kind of activity evolution prepared us for, pain can arise not from immediate threats, but from persistent low-level stress. The body interprets these signals as it once did, even though the causes differ from anything the ancestral world would have presented. Reproductive systems reflect ancient patterns as well. Human childbirth evolved under conditions where women were highly active, nutrition varied, and birth environments did not include medical support. The pelvis shaped itself around the demands of bipedal movement and upright posture, balancing those needs with the requirements of birthing large-brained infants. This compromise created challenges that persist today. Modern childbirth relies heavily on medical intervention not because evolution failed, but because the body was designed for circumstances that no longer exist. Nutrition, lifestyle, and activity patterns all influence pregnancy and delivery in ways that differ greatly from ancestral conditions. Emotional responses also demonstrate how mismatched the body can be to modern life. Hormonal systems that once managed short-term threats now activate in response to ongoing pressures that don't resemble immediate physical danger. Stress evolved as a tool for survival, meant to activate briefly in dangerous moments. But modern stressors, deadlines, social expectations, financial concerns, persist without the physical outlet that the stress system expects. The result is a physiological response that overfunctions in situations evolution didn't anticipate. The body reacts as if danger is imminent, even when the threat is conceptual or distant. The immune system presents another example of a body shaped by a world full of dirt, parasites, and constant exposure to a wide variety of microorganisms. It evolved to handle challenges encountered regularly by early humans. Today, cleaner environments, controlled sanitation, and medical treatments change the nature of immune exposure. While these improvements reduce illness, they also reduce opportunities for the immune system to learn in the ways it once did. In some cases, this shift is linked to increased sensitivity, allergies, or autoimmune conditions. The immune system still prepares for a world full of pathogens, even when the reality is different. Teeth provide yet another mismatch. Early humans used their teeth for tasks that extended beyond eating. They chewed tough plants, cracked shells, tore raw meat, softened fibers, and processed materials that required strength and durability. Their dental arches developed under significant pressure from abrasive foods. Modern diets don't challenge the jaw in the same way. Softer foods reduce strain, altering how teeth align. Crowded teeth and impacted wisdom teeth become more common, not because evolution miscalculated, but because the world changed faster than the jaw could adapt. Vision adapted for environments with natural light, long distances, and varied landscapes. Eyes were used for tracking prey, identifying edible plants, noticing movement, and navigating complex terrain. Now, many people spend significant time focusing on close objects in artificial lighting conditions. The eye was not designed for prolonged periods of reading or screen use. The rise in nearsightedness in many populations reflects a body adjusting to demands that differ significantly from those found in ancestral environments. This mismatch extends into cardiovascular function. Early humans engaged in constant moderate activity. Their hearts were conditioned for endurance, not for long periods of inactivity followed by short bursts of exercise. Modern lifestyles often reverse this pattern. The cardiovascular system responds by struggling with conditions that rarely affected early humans. The heart is capable of handling stress and activity, but it prefers predictable rhythms that resemble the life it evolved to support. Respiratory systems also reveal a shift. Early humans lived in open-air environments where movement and physical exertion were constant. Their lungs expanded frequently through activity that encouraged deep breathing. In modern settings, shallow breathing becomes common due to extended periods of sitting, stress, and indoor environments. This doesn't damage the lungs, but it doesn't challenge them in the ways evolution intended. They remain capable of high performance, yet they rarely reach their potential. All of these examples point to one overarching reality. The human body was not built for modern conditions. It was built for a world of variability, danger, scarcity, and constant movement. But that world faded as humans reshaped their surroundings. The body didn't adjust at the same pace as cultural and technological changes. Evolution works slowly. Societies transform quickly. This difference in speed created a situation where physical traits remain rooted in a past that no longer exists. None of this suggests the body is failing. It remains extraordinarily capable. It simply responds to rules written by a world that demanded things modern life no longer requires. The mismatch highlights why evolution appears to have slowed. If the environment no longer forces significant physical adaptation, the body maintains the traits that once served it well, even when those traits don't align perfectly with current lifestyles. At some point in the human story, the conditions that once shaped our species so forcefully began to fade, almost like distant sounds slowly drifting out of hearing range. Not all at once, not because of a single invention or discovery. The shift happened over thousands of years, building quietly as humans became increasingly skilled at smoothing out the rough edges of survival. When we look at evolutionary history, the most powerful driver of change is pressure. Real pressure. The kind that decides without hesitation who continues and who doesn't. When those pressures weaken, even slightly, the pace of biological evolution shifts. And once pressures vanish almost entirely in certain areas, the process slows to such a degree that it becomes difficult to see any major changes at all. To understand how these pressures disappeared, it helps to start with the way early humans lived. Their days were shaped by uncertainty. Weather changed abruptly. Predators stalked the same spaces they needed to gather food. Illnesses arrived without warning and had to be endured without medical solutions. Injuries could end lives quickly. Even something as simple as a cold night with inadequate shelter could determine whether a newborn survived. These conditions were exhausting, but they kept evolution active. Every generation faced challenges that selected strongly for specific traits. Gradually, however, behaviours and tools emerged that reduced the immediate impact of these hazards. Once individuals began sharing resources, the risk of starvation declined somewhat. Once fire became a controlled part of daily life, cooking increased calorie intake and provided warmth. This wasn't a sudden disappearance of pressure, but a noticeable easing. More individuals survived simply because cooperation and knowledge softened the effects of the environment. Evolution still acted, but with less precision. It no longer faced a narrow set of constraints. Instead, it navigated a growing web of cultural solutions that altered what counted as advantageous. As groups expanded and communication grew more effective, coordinated actions replaced isolated survival strategies. A single person no longer had to possess every needed skill. Strength could be compensated by planning. Speed could be supported through teamwork. Injuries could be managed with help from others. All of this diluted the influence of natural selection. A trait that might once have prevented an individual from surviving long enough to reproduce no longer held the same consequences when a community could step in to support that individual. Agriculture amplified this shift dramatically. Once humans began cultivating crops and domesticating animals, food scarcity changed shape. It didn't vanish, but it became far more predictable. The physical demands of hunting and gathering eased. Survival no longer depended entirely on endurance, alertness, or instinctive knowledge of landscapes. With stored food, communities could survive lean periods that would have devastated earlier groups. When a population's survival becomes less dependent on specific physical traits, evolution becomes less directional. Before agriculture, traits like metabolic efficiency, mobility, and resistance to starvation shaped reproductive success. After agriculture, these traits lost some of their influence. Living in stable settlements introduced a new dynamic as well. Shelter became more reliable. Structures protected against extreme weather, reducing the pressure on bodies to adapt to harsh climates. Clothing further insulated humans from environmental demands. While these improvements didn't eliminate physical challenges, they redistributed the balance of pressures. Instead of constantly reacting to nature, people created spaces where nature's influence weakened. This allowed individuals who might have struggled in previous eras to thrive. The development of medicine changed things even more. Early medical practices, even without advanced scientific understanding, represented a significant step toward protecting individuals from threats that once shaped human biology. Herbal treatments, wound care, and basic sanitation offered survival advantages that had nothing to do with inherited traits. A person who might have succumbed to infection could survive with even rudimentary care. As medical knowledge grew, especially in the last few centuries, the range of conditions that once served as powerful selective pressures narrowed further. Antibiotics, vaccines, clean water systems, and surgical procedures all diminished the force of natural selection. Where evolution once acted swiftly and brutally, modern interventions reduced the stakes. Nutrition expanded rapidly as global trade networks formed. Regions no longer relied exclusively on local food sources. When one crop failed, others could be imported. This weakened the selective pressures tied to local environments. For instance, traits that once supported survival during regional famines lost relevance when food came from distant areas. Even conditions like vitamin deficiencies, which once shaped physical development, grew less common with diversified diets and fortified foods. The disappearance of predators contributed to the vanishing pressures as well. Early humans faced animal threats that influenced their behavior and physiology. Quick decision-making, spatial awareness, and coordinated defense mattered deeply. As humans developed tools and structures that neutralized these threats, predators became a minor concern rather than a constant danger. This reduced the selective advantage of traits linked to vigilance and reflex responses. Technology contributed yet another layer to this change. Once people began building tools that enhanced their abilities, natural limitations became less relevant. Weak eyesight could be corrected with lenses. Poor hearing could be supplemented by devices. Missing limbs could be compensated with prosthetics. Tools extended human capabilities far beyond what genes alone could provide. Evolution no longer needed to refine certain physical features, because technology filled the gaps. Social structures added another dimension to the reduction of pressures. Communities created systems that protected vulnerable individuals, redistributed resources, and established norms that prioritized group stability. These systems ensured that individuals with genetic disadvantages could still survive and reproduce. Where evolution would once have filtered out traits that hindered survival, social support systems allowed them to persist. This didn't harm the species, it simply reduced the intensity of natural selection. Even reproduction underwent change. In earlier eras, reproductive success depended heavily on physical capability, resource acquisition, and survival over many years. Modern reproductive patterns, shaped by personal decisions rather than strict survival demands, shifted the determinants of who passed on their genes. Traits once essential for raising offspring became less tied to biology and more tied to cultural choices. Evolution's influence diminished accordingly. As pressures weakened, genetic diversity increased. In harsh environments, only a narrow set of traits may survive. In more forgiving environments, a wider range persists. This expansion of diversity doesn't mean evolution stopped. It means evolution lost its sharp edges. Instead of shaping humans towards specific directions, it allowed variation to flourish. This variation doesn't produce rapid evolutionary change, but it reflects a species no longer guided by strict environmental demands. Globalization further softened pressures. Human populations, once isolated and shaped by distinct environments, began mixing. Genetic differences that might have become pronounced remained diluted. Diverse gene pools combined, making strong local adaptations less common. While some regional adaptations still exist, their impact is far less influential when populations interact extensively. Another important factor involves safety. Early humans lived with significant risks from accidents, animal encounters, severe weather, and infections. Today, most people live in environments where these risks are drastically lower. Homes protect from storms, transportation reduces physical exertion. Laws regulate dangerous conditions in workplaces. Medical systems treat injuries that once were fatal. With these protections in place, evolution has fewer opportunities to apply pressure through survival differences. Even emotional pressures have shifted. Fear, once triggered by immediate physical threats, now responds largely to abstract or long-term concerns. The emotional system is still tuned to ancient dangers, but the world it responds to no longer resembles the one it evolved in. This mismatch contributes to modern stress patterns, but doesn't exert evolutionary pressure in the way ancient fears once did. Stress once functioned as a survival tool, sharpening instincts and encouraging decisive action. Today, it often arises in settings unrelated to physical danger, reducing its evolutionary relevance. Cultural evolution also plays a major role in the disappearance of pressures. Ideas, knowledge, and systems can change faster than genes. When culture solves a problem in a single generation, evolutionary mechanisms don't have time to respond. For instance, improvements in sanitation resolved many health challenges far more quickly than biological adaptation could. Similarly, education system provided knowledge that helped individuals navigate complex environments, reducing the influence of instinctive behavior patterns shaped by earlier pressures. The modern world is full of examples where cultural solutions replaced biological ones. Transportation overrides the need for physical endurance. Agriculture overrides the need for regional adaptations to food availability. Communication tools override the need for certain memory skills. These shifts don't make the body obsolete. They simply change what matters most for survival and success, often leaving evolutionary mechanisms without their former influence. With the disappearance of pressures also comes a tendency for traits that once held great importance to persist even when they're no longer necessary. For example, the instinct to consume high-calorie food survives, despite living in conditions where such foods are abundant. The tendency to respond strongly to sudden sounds remains even without predators in daily life. These traits endure because evolution removed pressures but didn't reverse their effects. Once a trait becomes embedded in the species, it doesn't vanish simply because the environment changes. Without strong selective pressure to remove it, the trait persists. All of these changes contribute to an important realization. Evolution didn't reach a formal stopping point. It simply lost its most influential forces. These vanished pressures create the illusion of stagnation, but what's actually happening is a redirection. Humans live in a world shaped by their own decisions. Those decisions reduce the role of genetics and increase the role of culture, creating a species that evolves more through ideas than through DNA. It's hard to point to a single moment when culture stepped in and quietly took the reins from natural selection, yet the transition is one of the clearest turning points in the human story. Instead of being shaped primarily by hardships, danger, scarcity, and random chance, people began shaping themselves through choices, traditions, knowledge, and shared expectations. Culture didn't replace biology deliberately. It simply grew layer by layer until the balance shifted. What began as simple learned behaviors eventually became an entire system that guided survival more strongly than inherited traits ever could. The earlier signs of this shift appear in small, practical habits. When one group realized that sharpening stones created better tools, that knowledge spread. The individuals who weren't naturally skilled at hunting or gathering could still succeed by learning from others. Culture became a reservoir of solutions stored outside the body. Instead of relying on instincts alone, humans relied on each other. With enough shared knowledge, genetic disadvantages mattered less. A person didn't need exceptional physical strength if they had access to a strong tool. They didn't need perfect memory if their community developed ways to preserve information. Every piece of culture that added stability diminished the precision with which natural selection shaped the species. At first, these cultural shifts might seem minor, almost trivial, but their cumulative effect was enormous. When communities developed norms, how to divide tasks, how to teach children, how to settle disagreements, those norms created predictable environments. Predictability reduces selective pressure. A stable society cushions individuals from random misfortune. It reduces the number of situations where survival depends on specific biological traits. Natural selection thrives on unpredictability. Culture weakens it. Language magnified this effect dramatically. Once humans had reliable communication, ideas survived longer than any single lifetime. People could teach methods, pass on strategies, and preserve lessons that would have been lost in earlier generations. Cultural knowledge accumulated. It didn't rely on slow genetic changes. It advanced through learning, imitation, and improvement. A new idea could spread through a group in months. A genetic change might take tens of thousands of years to have measurable impact. Culture operated on a completely different timescale, far faster than biology could ever match. As language grew more complex, so did the systems built on it. Social rules expanded, communities developed shared identities. Rituals emerged to reinforce cooperation. These systems reduced the necessity for individuals to rely on biological instinct for survival. They learned instead. A species that learns rapidly experiences less pressure to evolve biologically. If a child can be taught what plants are dangerous, or how to escape a threat, evolution no longer needs to refine a built-in instinct for those tasks. Knowledge fills the gap. Once agriculture developed, cultural systems took another major step forward. Food abundance became a product of planning rather than luck. Farming required cooperation, organisation, and division of labour. These cultural structures reshaped human life so completely that many traits rewarded in hunter-gatherer societies lost their importance. Endurance mattered less when food could be grown nearby. Resistance to starvation mattered less with stored grain. Adaptations that supported nomadic lifestyles faded in relevance when people settled in permanent homes. Natural selection no longer guided who thrived in clear, consistent ways. Culture set the conditions instead. Laws and norms added yet another layer of insulation. As societies grew, conflicts arose, But instead of resolving them through dominance or physical strength, people turned to rules. Rules redistributed power in ways unrelated to size, speed, or inherited traits. A physically strong individual no longer had automatic authority. Leadership became tied to social influence, strategic thinking, persuasion, or lineage. These qualities often had cultural origins rather than genetic ones. Natural selection used to reward the individuals best suited to the physical demands of survival. Culture rewarded the individuals best suited to social expectations. One of the most striking examples of cultural influence appears in health. Before modern medicine, cultural practices, sanitation rituals, herbal remedies, midwifery, wound treatments reduced mortality. Even imperfect practices were enough to alter evolutionary pressures. If a dangerous infection could be treated culturally, the pressure to develop genetic immunity decreased. Over time, as medical knowledge expanded and improved, the link between genetics and survival weakened further. Modern medicine has reduced the impact of many conditions that once shaped human biology. A person born with a trait that might have previously reduced lifespan can now live a full life. Because of this, natural selection near the edges of modern medical access is much softer than it once was. Technological development accelerated this shift. A tool can compensate for physical limitations so effectively that traits once heavily selected lose their relevance. Weak eyesight becomes manageable with lenses. Poor mobility can be supported with devices. Difficulty obtaining food no longer reflects personal survival traits, but economic and social structures. Technology allows individuals with a wide variety of biological characteristics to thrive. In earlier eras, survival depended more directly on the body. Now, survival depends heavily on the systems human communities have built. Education systems intensified the replacement of natural selection even further. In most societies, children spend years absorbing knowledge that helps them navigate a world filled with cultural complexity. A child doesn't need survival instincts shaped over millennia. They need skills shaped by the society they live in. This means the determinants of success come from learning rather than genetics. Cognitive flexibility matters, but cultural exposure expands that flexibility far more quickly than evolution could. In this sense, culture trains the brain as much as biology forms it. Another way culture replaced natural selection is through mate choice. In the distant past, reproductive success was tied closely to physical traits that influence survival. Strength, endurance, disease resistance, and resource acquisition shaped mating patterns. But as societies formed and social norms grew stronger, the criteria for choosing a mate shifted dramatically. Preferences began reflecting cultural values: status, kindness, humour, shared beliefs, artistic skill, traits that often have little direct connection to biological fitness. When culture guides mate choice, evolution loses one of its oldest pathways. This shift also influenced population dynamics. Communities began supporting individuals who might not contribute directly to food acquisition or defence. Elders provided knowledge. Children learned slowly but eventually contributed to culture. People with physical disabilities could still become valued members of their groups. These inclusive structures reduced natural selection's opportunity to remove certain traits from the gene pool. Instead of filtering out variation, society preserved it. Cultural expectations also determine which skills are rewarded. For example, writing became important in many societies, yet literacy has no direct genetic foundation. A child isn't born with reading instincts. They learn through cultural systems. People who excel in writing aren't necessarily transmitting biological advantages. They're transmitting learned skills that their children may or may not adopt. In this sense, culture creates its own version of inheritance independent of genetics. Even physical activity transformed through culture. Where endurance once shaped anatomy, sports and exercise now shaped bodies at an individual level without influencing evolution. Someone who trains intensely becomes stronger during their lifetime, Yet their offspring do not inherit these gains. Cultural practices produce changes within individuals rather than across generations. Biology stays the same while behavior adapts fluidly. Transportation offers another example of culture superseding biology. In earlier times, distance and terrain limited movement. Over generations, bodies adapted to local environments because people rarely travelled far. Natural selection shaped populations according to conditions of climate, altitude, and available food. Once humans developed long-distance transportation, local adaptations became less relevant. People moved freely, mixed with distant groups, and exchanged genetic traits across regions. Cultural mobility dissolved many environmental constraints that once guided evolution. Economic systems contributed to this transformation as well. In modern societies, survival often depends more on employment, resource distribution, and social stability than on inherent biological traits. Someone who is physically weak can still thrive in roles that require planning, communication, or creativity. Someone who is highly athletic may not necessarily have an evolutionary advantage. Economic success and resource access are guided by cultural structures, education, opportunity, market conditions, rather than natural selection. As culture grew more influential, the types of challenges humans faced changed. Threats shifted from immediate physical dangers to long-term structural concerns, social stress, economic insecurity, environmental changes. These challenges do not directly influence survival in ways that shape genetic selection quickly. They influence behavior instead. Behavior responds far faster than evolution can. A community can adapt culturally to a challenge within a generation. Evolution cannot. As natural selection faded from the forefront, cultural evolution took its place. Ideas, technologies, and norms adapted quickly. Problems were solved through knowledge rather than genetics. When fires threatened homes, people invented methods of construction that reduced risk. When diseases spread, people developed sanitation practices and medical treatments. When climates became challenging, people created clothing and architecture suited to new conditions. Each cultural advancement made biological adaptation less urgent. This redirection does not mean genetics stop shifting altogether. Evolution continues quietly, influenced by subtle patterns, disease resistance, environmental exposures, mutation rates. But these influences are weak compared to the powerful cultural systems built around them. Evolution now works in the background rather than guiding the species directly. Culture dominates the everyday experiences that determine survival, reproduction, and long-term success. A defining difference between biological and cultural evolution lies in speed. Natural selection operates slowly, requiring generations before significant changes appear. Culture evolves almost instantly by comparison. A single new idea can transform millions of lives in a few years. When an adaptive solution arises culturally, it spreads so quickly that evolution cannot compete. The brain's earlier expansion made this possible. Once ideas became the primary tool for survival, culture overshadowed the mechanisms that shaped the species for millions of years, and this brings the story to a moment where the species finds itself guided mainly by the systems it created. Natural selection still exists, but it doesn't steer the direction of human life the way it once did. Culture decides which traits matter. Technology extends human potential beyond biology's limits. Social structures determine survival more strongly than physical traits. The environment that once shaped our ancestors has been replaced with environments humans designed themselves. There's a point in human history where tools stopped being extensions of the hand and became extensions of the mind. Before that shift, humans used objects to improve their physical reach or to make tasks easier. After that shift, technology began shaping the direction of the species just as strongly as the environment once did. Not because tools altered DNA directly, but because they changed the meaning of survival. When the right tool could overcome danger, distance, scarcity, or discomfort, biological traits lost much of their influence. A person didn't need the strength of earlier ancestors if a tool could multiply their force. They didn't need exceptional senses if instruments could detect what eyes and ears could not. They didn't need to adapt physically to every changing climate when technology could build shelters, clothing, and controlled environments. Technology became the new architect of human change by stepping into roles nature once filled. The earliest tools seem simple now, but they transformed how humans interacted with the world. A sharpened stone shifted the balance between predator and prey. A digging tool increased access to foods that would have been unreachable. Over time, these objects accumulated into a toolkit that allowed humans to navigate environments that would have defeated them otherwise. But the real transformation came when technology changed how humans thought, not just how they acted. Using tools required planning, memory, cooperation, and imagination. These mental abilities became more central to survival than raw physical ability. The toolmaker, the planner, the communicator, and the strategist grew just as valuable as the physically strongest individuals. Technology rewarded mental capabilities in ways natural selection never did, and that reward reshaped which traits mattered most. As tools improved, so did the stability they provided. Stability reduces selective pressure. When a tool can solve a problem, evolution doesn't need to refine a genetic response. A perfectly evolved hand isn't necessary if a well-designed tool can replace its function. A perfectly adapted metabolism isn't as crucial when cooking and storage ensure a steady food supply. A perfectly protective body isn't required when clothing and shelter block environmental hazards. Natural selection thrives when the environment imposes strict demands. Technology replaces those demands with choices, often softening or removing them entirely. Once humans learned to control fire consistently, the relationship between body and environment changed forever. Fire provided warmth, protection, and a way to transform food. Cooked meals offered more calories, and those calories fed the growing brain. But the important part is not the calories themselves, it's that fire reduced the pressure to evolve new digestive traits. Instead of adapting biologically to difficult foods, humans adapted culturally. Cooking allowed earlier ancestors to eat things their bodies weren't naturally optimized for. This meant evolution no longer needed to reshape teeth, jaws, or guts as drastically. A cultural solution replaced a biological one. Thousands of years later, tools became more specialized. When hunting weapons improved, physical power became less central. A spear thrown from a distance required accuracy and coordination more than brute strength. Later, when archery developed, the advantage shifted again. The strongest hunter was not always the most successful. Precision, patience, and understanding of animal behavior mattered more. As tools evolved further into traps, nets, and later projectile technology, the role of raw physical traits diminished. Instead of evolution favoring individuals with certain body types, technology broadened the range of people who could contribute successfully. This shift became even clearer with the development of agriculture. The earliest farming tools allowed people to shape landscapes, store food, and control their resources. For the first time, entire communities could survive without constant travel or physically demanding hunting routines. This altered the connection between body and environment. People no longer adapted to local food sources through genetic change. They adapted through farming techniques, irrigation, crop selection, and food storage. These were technological and cultural adaptations, not biological ones. The body remained largely the same even as environments became increasingly artificial. As time moved forward, technology began influencing survival in ways evolution could never match. When shelters improved, climate mattered less. People could live in cold regions without developing thick fur, or in hot regions without evolving new cooling mechanisms. Clothing became a layer of artificial fur, and insulation became a layer of artificial fat. people shaped the world instead of letting it shape them. The environment that once guided evolution now reflected human design. Navigation tools extended this shift even more. People once navigated by stars, landmarks, memory and instinct. Later technologies, maps, compasses and eventually digital tools, meant individuals did not need inherent spatial awareness to travel effectively. The reliance on learned or external tools reduced the importance of genetic predispositions for navigation. People could traverse oceans, deserts, and forests without biological adaptations that other species required for such movement. Technology replaced instinct with knowledge and precision. Medicine became one of the strongest forces replacing natural selection. Before medical technology, survival depended heavily on biological resilience. Diseases eliminated individuals with weaker immune responses. Injuries ended lives rapidly. Childbirth carried enormous danger. But with even basic medical tools, the survival landscape changed. Herbs, stitching methods, clean water practices, and early surgical procedures extended life in ways that genetics alone could not. As medicine advanced, even individuals who inherited conditions that might once have prevented reproduction could survive and contribute to the gene pool. Modern medicine amplified this dramatically. Vaccinations, antibiotics, prenatal care, and surgical interventions protect lives that evolution might not have preserved. Technology replaced many of the filtering mechanisms natural selection once relied on. Transportation technologies removed yet more evolutionary pressures. Once humans developed boats, wheels, and later engines, physical limitations about distance became irrelevant. Populations mingled, reducing isolation. Isolated groups experienced strong selective pressures that produced distinct adaptations. When groups merge, those adaptations dilute. Technology increased global interaction, making evolution less directional. Differences that might have grown into major biological divergences blended instead. A world connected through technology does not allow regional adaptations to form easily. Communication technologies expanded the reach of culture even further. Spoken language already allowed knowledge to spread within communities. Writing allowed it to spread across generations. Printing allowed it to spread across continents. Digital technology allows it to spread across the entire planet instantly. Knowledge once transferred through slow teaching now moves through systems that reach billions. Biological evolution cannot keep pace with this speed. When new ideas solve problems more quickly than genetic changes can, the environment exerts almost no evolutionary pressure. Technology becomes the main influence on behavior, opportunity, and survival. Artificial lighting added yet another twist. The body evolved to follow natural cycles of day and night. Artificial light changed sleep patterns, activity cycles, and even emotional regulation. Instead of adapting biologically to these changes, humans adapted through technology, routine, and cultural norms. The brain now navigates environments filled with signals evolution never anticipated. Screens, lamps, neon signs, and glowing tools extend wakefulness far beyond the body's natural rhythm. Yet sleep persists using ancestral systems that do not fully align with modern patterns. This mismatch doesn't reshape evolution significantly because technology adjusts behavior faster than genes can. Hygiene innovations produce profound effects on survival as well. Clean water systems, waste management, and sterilization practices reduced infections that once shaped populations. The immune system, designed for environments filled with constant microbial exposure, now functions in a very different context. But because culture replaced the selective pressure of diseases with sanitation, evolution had no need to refine immune systems further. Instead of developing stronger natural defenses biologically, humans develop external defenses through technology. Manufacturing tools transformed strength into a far less critical trait. Machines lift, cut, shape, carry, and build. People once needed physical power to move heavy objects or construct shelters. Now, tools do the lifting. Someone lacking the physical attributes that once mattered deeply can still perform roles requiring strength, because machinery amplifies human ability. Evolution doesn't need to make stronger bodies when technology provides strength externally. Information storage tools influenced memory. Early humans needed strong memories to track seasonal patterns, migration routes, edible plants, and dangers. Today, memory is supplemented by notes, recordings, books, and digital devices. People rely on external systems to store information outside their minds. This reduces selective pressure on cognitive traits tied to recall. The brain remains capable, but memory becomes more of a learned skill than a genetic advantage. Nutrition technology changed how people eat entirely. Refrigeration, preservation methods, and global trade allow access to foods that no local environment could ever supply consistently. The body still expects periods of scarcity and high physical activity, but the modern world rarely provides either. Instead of evolving new metabolic systems, humans create diets, guidelines, and nutritional science to manage health. Technology fills the role natural selection once played in regulating resource availability. Energy systems transformed environments more dramatically than any earlier tool. Once humans harnessed electricity, the entire structure of daily life shifted. Work hours, entertainment, communication, and movement reorganized around power systems. Evolution had no chance to adjust because the changes happened too fast. These shifts prioritized technological literacy, flexibility, and adaptation to artificial environments over traits shaped by nature. Digital technology accelerated these patterns. People interact with screens more than they interact with natural landscapes. The brain responds to symbols, images, messages, and rapid information streams. None of these stimuli existed in the ancestral world. Technology created an environment that shaped behavior long before genetics could adapt to it. Even social relationships are influenced by digital systems. Friendships, communication styles, and community networks no longer depend on physical proximity. Evolution once rewarded traits suited for managing face-to-face connections in small groups. Technology created social structures far larger and more complex than those early patterns. The traits that matter now, digital literacy, communication across distance, managing constant information, are learned, not inherited. Artificial intelligence introduces another dimension. Systems capable of analyzing data, predicting outcomes, and automating tasks extend human capability beyond anything earlier technology allowed. As these systems grow more integrated into daily life, they further reduce selective pressures tied to memory, problem-solving, or spatial reasoning. A person can rely on technology to guide navigation, choose resources, or interpret patterns. Evolution does not select for these traits anymore because tools perform them externally. Even emotional experiences are shaped by technology. Entertainment systems provide stimulation, distraction, or comfort at a speed and intensity unmatched in nature. People adjust behavior around these technologies through culture, preference, and routine. Evolution has no foothold in this process because the emotional system still follows ancient rules, even as technology creates new contexts for them. In all these ways, technology acts as a shield against natural selection. It prevents the environment from exerting strong pressures. It allows individuals with a wide range of traits to succeed. It spreads solutions instantly. It replaces physical, cognitive, and environmental challenges with artificial substitutes. This doesn't diminish the human story, it expands it. But it also redirects evolutionary pathways so profoundly that major biological changes become unlikely in the near future. It can feel surprising to think that genes, the microscopic instructions that once sprinted through human history under the weight of constant pressure, now move through generations with a kind of meandering ease. They're not being pulled strongly in one direction the way they were when survival hinged on sharp instincts. durable bodies, and rapid adaptation to unpredictable landscapes. Instead, they drift in a vast, complex population that no longer funnels them through narrow filters. In earlier eras, only certain traits had a real chance of carrying forward. Now, countless variations continue with little interference. The human genome hasn't stopped changing. It simply wanders without urgency, shaped by conditions that are far gentler than the ones our distant ancestors faced. In small, ancient communities, natural selection acted with a blunt and immediate force. If a trait hindered survival, it seldom stayed in the population for long. Genes that supported endurance, disease resistance, temperature tolerance, or efficient digestion spread quickly because individuals possessing them had a direct advantage. Modern populations, however, do not face such tightly controlled conditions. Billions of people across the world share genetic material through migration, intermarriage, and global travel. This mixing dilutes the influence of any single local environment. Where genetic differences were once shaped by climate or terrain, today they blend into a global pool with no single set of demands pulling them into a precise direction. A useful way to imagine this is by comparing two very different systems. In the past, genes travelled through small channels. A drought, a cold season, a scarcity of food, or a rise in predators narrowed those channels further. Only certain combinations of traits passed through. But in the modern world, those narrow channels have widened into broad plains. Genes drift across them with little restriction. Almost anything that isn't directly harmful can persist, because the environment no longer eliminates it swiftly. This is one of the clearest explanations for why human evolution appears to have slowed. The urgency that once guided genetic selection simply isn't present anymore. Medical advancements amplify this shift. Traits that would have prevented survival in previous eras often pose little obstacle today. A person born with a genetic condition that would have proven fatal thousands of years ago can now live a long, meaningful life. This doesn't remove the condition from the gene pool, it preserves it. Some might think of this as working against evolution, but it's more accurate to say that it changes evolution's nature. Instead of genes being filtered harshly, they persist even when they don't contribute to survival. The ability to treat or manage medical conditions removes some of the pressure that once shaped reproductive patterns. Another factor influencing genetic drift is the sheer size of the modern human population. Evolution happens fastest when populations are small and selective pressures are strong. The smaller the group, the quicker any useful mutation spreads. But with billions of people on Earth, even beneficial mutations are diluted within the vast genetic landscape. They still spread, but at a pace that's almost invisible on a generational scale. It's not that mutations have stopped. They continue as they always have. What's changed is the speed at which they influence the species. A new, advantageous gene in a population of 10,000 can reshape that group in a few hundred generations. In a population of 8 billion, it may remain a subtle variation for thousands or tens of thousands of years. The reduction of isolated communities also plays a major role. Human groups were once separated by mountains, oceans, deserts, and lengthy distances that limited gene flow. Each group evolved traits suited to its local conditions, creating distinct patterns across the globe. Differences in skin tone, body proportions, lactose tolerance, altitude adaptations, and other regional traits reflect those historical pressures. But as travel and migration increased, these groups blended, genetic boundaries blurred. Variations that might have grown into entirely new traits instead dispersed. When differences spread across wide populations, they lose the momentum required to evolve rapidly. Instead of diverging, humans converge genetically, even while maintaining broad diversity. It's important to note that genes are still reacting to the environment, but the environment itself has transformed. People live in artificial surroundings with controlled temperatures, processed foods, sheltered homes, medical systems, and cultural practices that cushion them from natural challenges. When the environment becomes human-made, evolution loses much of its influence. Indoor temperature regulation means genes no longer need to adapt to harsh climates. Global food distribution means genes no longer respond strongly to local diets. Safety systems mean genes no longer need to refine physical responses to danger. These conditions lead to a world where variation persists simply because nothing forces it into narrower patterns. A subtle yet fascinating part of this drift relates to the modern diet. Humans once consumed foods that required physical effort to gather and digest. Now, diets often include concentrated calories, refined ingredients, and consistent availability. Some individuals metabolize these foods efficiently, others struggle, but because food is abundant, there is no strong evolutionary push to favor one metabolic trait over another. Even when modern diets create health challenges, medicine and lifestyle changes soften the impact. As a result, genes tied to metabolism drift without the strict guidance they once received. They don't race toward optimal efficiency. They wander within the boundaries of a world that supplies more food than the body evolved to expect. Reproductive patterns have also changed dramatically. In older societies, the number of children an individual had was tightly connected to survival traits. Strength, resourcefulness, and resilience shaped reproductive success. Now, family size often depends on social, economic, educational, or personal choices. Genetics plays a role, but not in the straightforward way it once did. Someone with excellent physical traits may choose not to have children. Someone with genetic vulnerabilities may choose to have several. These decisions are guided by culture rather than biological necessity. Cultural choices influence the distribution of genes far more strongly than natural selection does. Gene flow across populations also produces an interesting effect. Because humans now mix more freely than ever before, genetic variations that were once rare in one region might appear more frequently as populations intermingle. But instead of creating new local adaptations, this blending creates a balanced assortment of traits that drift through the global population at a slow, steady pace. Differences no longer deepen into distinct evolutionary paths. They merge into a worldwide mosaic of variations that change so gradually that single generations barely notice them. Another layer of genetic drift involves modern health interventions that allow people to live and reproduce despite conditions evolution would have strongly filtered. For example, individuals with severe allergies, chronic illnesses, or inherited metabolic disorders can manage their conditions with medical support. This doesn't eliminate those traits from the gene pool, it protects them. Over time, the genetic landscape becomes more diverse, not less. Natural selection once worked like a sculptor, chiseling away traits that didn't fit the environment. Now it behaves more like a curator, stepping back while culture and medicine determine which traits remain part of the collection. It's also worth recognizing that the human genome carries large amounts of neutral variation, changes that neither help nor harm. These variations accumulate quietly. In environments with strong selective pressure, even neutral traits can become significant if linked to survival-related genes. But in the modern world, these variations drift freely. They don't rush into new forms. They don't disappear quickly. They simply persist, shaping the subtle uniqueness of individuals without creating sweeping, species-wide patterns. Another consideration is that the environments humans create today are more variable culturally than biologically. Cultural environments change faster than genes can follow. A new technology can reshape daily life within a decade. A new social norm can alter behavior within a few years. But these shifts don't provide stable selective pressures. Evolution responds to consistency. Culture removes that consistency by changing rapidly. The body may still respond biologically to stress, diet, or lifestyle, but these conditions shift too quickly to guide long-term genetic change. The result is a world where genes no longer operate under urgent deadlines. They follow their own slow rhythm, one that continues quietly in the background. Mutations arise, Some persist, some fade, some spread gradually. But without strong environmental pressures pushing the species in a specific direction, these genetic shifts remain subtle. In earlier times, a single genetic mutation could influence survival dramatically. Now, survival is influenced more by access to resources, medical care, education, and cultural systems than by inherent genetic differences. This doesn't mean evolution has stopped entirely. Some areas still show signs of continued change. Lactose tolerance evolved in groups that adopted dairy farming. Certain regions developed adaptations to high altitudes. Resistance to specific diseases evolved in populations exposed to them over long periods. But these examples highlight a key point. Evolution now requires very specific, enduring conditions to influence the genome meaningfully. The widespread disappearance of such conditions means biological evolution acts with a much lighter touch. One particularly interesting effect of this gentle evolutionary climate is how genetic variation can now spread globally without creating strong advantages or disadvantages. In early human history, a trait that provided even a slight advantage could dominate a population. Today, that same trait may exist for thousands of years without becoming widespread because survival no longer depends on it. Instead of racing to fix beneficial mutations, the gene pool meanders through generations, guided more by chance and cultural patterns than by natural selection. Some people imagine that future human evolution might accelerate again if new pressures appear, climate change, disease outbreaks, or technological dependency. But even these pressures operate differently from ancient ones. Modern challenges often trigger cultural or technological solutions before biological evolution has time to respond. Acute dangers tend to be solved by the tools humans build. Long-term challenges are softened by global cooperation or technological innovation. Evolution might still react to these pressures, but it will do so slowly, overshadowed by cultural responses that move faster. The lingering question, then, is what this means for the future. If genes are wandering rather than racing, if biology is no longer the main driver of human change, where does that leave the species? The question of whether humans are still evolving often comes up in conversations about our future, and it tends to sit in a space between scientific curiosity and everyday wonder. Some people imagine evolution as a constant forward march, a process that never stops pushing a species toward improvement. Others assume that once technology and culture became dominant, the biological part quietly stepped aside. The reality, though, doesn't fit neatly into either of those assumptions. Humans are changing, but the change doesn't look anything like the intense high-pressure evolution that shaped early ancestors. Instead, what's happening now resembles a slow drift, a gentle movement rather than a directed surge, guided by forces far weaker and more scattered than those that once determined who thrived and who didn't. To understand this drift, it helps to revisit what evolution actually requires. It doesn't need dramatic mutations or sudden improvements. All it needs is variation, heredity, and some form of pressure that influences who reproduces and who doesn't. Those conditions still exist today. People are genetically diverse. They pass traits to their children, and they live in environments that create subtle patterns in survival and reproduction. But the pressures shaping those patterns are nothing like the ones our species encountered tens of thousands of years ago. The extreme conditions that once filtered the population with sharp precision have softened. In their place are influences that operate quietly, slowly, and sometimes unpredictably. Modern research shows that humans do continue to evolve in small ways. Certain populations develop slight changes in immune responses, alterations related to metabolism, or differences in responses to environmental factors like altitude or sunlight. These changes are real, measurable, and ongoing. Yet they unfold at a pace so slow that most people would never notice them without scientific tools. They lack the dramatic traits that once marked earlier evolutionary chapters, like major shifts in skull shape, brain capacity, or body proportions. Instead, they show up as minor adjustments. A gene variant that becomes a little more common here, another that fades slightly there. These shifts are the definition of drift. Movement without urgency, without a clear direction, and without the overwhelming pressure that forces rapid change. It might help to think about this in terms of momentum. Early humans lived with constant evolutionary momentum because life was hard in ways that directly affected survival. Every trait that improved hunting, gathering, child rearing, shelter building, or predator avoidance had immediate consequences. Those who possessed such traits often lived longer, had more children, and passed those advantages along. But once culture and technology began reshaping the environment, that momentum slowed. The world no longer required humans to evolve quickly. Tools handled challenges before evolution could respond. Knowledge spread faster than genes. Communities protected individuals whose traits might not have offered survival benefits in the past. Momentum didn't vanish entirely, but it softened into a slow, drifting motion. One of the clearest examples of this involves global mixing of populations. Ancient groups were isolated. They stayed in regions for thousands of years and developed specific adaptations: resistance to local diseases, tolerance for particular foods, skin pigmentation suited to sunlight levels, and even differences in lung capacity based on altitude. These adaptations formed because each group faced distinct pressures. But once travel, migration, and intermarriage expanded, isolated adaptations blended into a global genetic landscape. Biological differences that once diverged now merge. Without isolation, evolution loses one of its strongest drivers. The result is not stagnation but slow diffusion. Variations move through the population gently, neither speeding ahead nor disappearing suddenly. Another factor guiding the drift is the modern reduction of reproductive differences. In the past, individuals who struggled physically often had fewer children, while those well suited to local environments reproduced more. Now, reproductive patterns are shaped more by personal choice, financial circumstances, education, and cultural norms than by physical or genetic traits. This means that evolution doesn't have the clear reproductive signals it once relied on. Someone with a genetic condition might still choose to have children. Someone in excellent health might choose not to. These patterns break the direct link between biology and reproduction, weakening the selective forces that once guided evolution strongly. Medicine also plays a crucial part in this drifting pattern. Many genetic traits that once reduced survival now have minimal impact. A person with severe allergies or asthma or metabolic vulnerabilities can thrive with treatment. A child born prematurely can survive with medical support. Conditions that might have prevented reproduction in earlier eras no longer determine reproductive outcomes. This doesn't eliminate evolution entirely, but it means evolution now acts lightly, almost quietly, without the stark filtering of earlier times. But amid all this drift, there are still pockets of subtle evolution happening. These pockets show that humans haven't stepped out of the natural process entirely. For example, certain populations continue to develop improved tolerance for high-altitude living. Others show signs of changes in immunity linked to long-standing exposure to specific diseases. Some groups exhibit differences related to diet, like glucose metabolism or fat storage, that reflect long histories of certain food patterns. But even these examples don't unfold with the breathtaking pace of earlier evolutionary leaps. They progress slowly because the pressures shaping them aren't as severe or consistent as the forces that shaped our ancestors. This raises an important distinction. Evolution has not stopped, but the direction is harder to trace. In the past, stronger survival often meant stronger selection. Today, survival is influenced by systems built by humans, so biological selection is muted. Genes drift not because they lack variation, but because the environment no longer molds them with strong hands. They move like leaves in a calm current, changing position, adjusting slightly, drifting toward new combinations but rarely propelled by sudden, forceful shifts. There's also a unique complexity in the modern world that makes it hard for evolution to act decisively. The environment is too dynamic. Evolution thrives when conditions stay stable long enough for certain traits to become beneficial. But the world humans now inhabit changes rapidly because of cultural and technological shifts. One generation grows up without digital tools, the next grows up immersed in them. One group experiences one kind of diet, another experiences something entirely different. Stress, sleep patterns, social structures, and even exposure to microbes shift constantly. These quick changes do not give evolution enough time to establish clear selective pressures. Instead of steering traits in a stable direction, the environment fluctuates too frequently for long-term genetic change to take hold. The drift also becomes clearer when looking at neutral traits, genetic variations that don't help or harm survival. In a world with strong selection, many of these variations would fade over time or become linked to advantageous traits. But in the modern world, they persist simply because nothing removes them. They spread randomly, influenced more by chance, migration and reproduction patterns than by survival. This randomness is another hallmark of drifting evolution. Change without a goal, movement without direction, variation that spreads because the world allows it, not because the world requires it. Some scientists suggest that evolution may still influence humans in ways too subtle for us to notice. For example, there may be slight changes in reproductive timing, immune responses, or cognitive tendencies that only become visible over thousands of years. These shifts don't create dramatic physical changes, but might gradually influence internal processes. Yet even if such changes exist, they are overshadowed by cultural and technological factors that shape human life far more immediately. Someone's health, lifestyle, or family size is now determined by choices, opportunities, and systems rather than by inherited traits alone. This interplay of drift and subtle adaptation leads to a curious situation. Humans appear biologically stable, not because evolution has ended, but because environment and culture have changed so drastically that biology no longer carries the full burden of adaptation. The species adapts mainly through learning, innovation, and behavior. Evolution reacts to this new reality by slowing down, drifting, and waiting, in a sense, for long-term pressures that remain consistent enough to guide genetic change, but human-created environments shift too quickly for that waiting to resolve into clear direction. Yet it's important to point out that drifting does not mean decline. Drift is simply what happens when no strong forces push evolution in a particular direction. It reflects freedom rather than failure. When bodies are no longer refined by harsh conditions, variations that once would have been filtered out get to remain. That creates diversity rather than uniformity. It also allows individuals with a wide range of traits to thrive. In earlier eras, differences could determine survival. Now they shape identity, not life or death outcomes. Drift broadens the spectrum of human traits rather than narrowing them. If evolution were still racing, humans might be experiencing intense pressure to adapt physically to a changing climate, diet, or environment. Instead, humans adapt through technology. Air conditioning, clothing, medicine, agriculture, and communication tools. These systems make rapid biological adaptation unnecessary. They shield the species from immediate environmental demands and leave genes free to drift, accumulating slow changes that may someday matter but for now remain quiet. This blend of stasis and subtlety creates a moment in human history that feels different from all others. There is movement, but not urgency. Change, but not direction. Possibility, but not pressure. The species is still part of evolution, yet it is also the author of its own surroundings, and those surroundings reduce the natural forces that once guided every trait. Drift becomes the natural outcome of a species that solved its environmental challenges through culture faster than biology could keep up. Looking at the world humans have built, it becomes clear that the future isn't just something approaching from ahead. It's something people continuously shape from behind, layer by layer, decision by decision, innovation by innovation. Every structure, every system, every technology, and every cultural shift carries traces of choices made by countless individuals. Yet, as much as humanity molds its surroundings, those very surroundings push back in ways that influence how people live, think, and adapt. The future humans create becomes the future that shapes them. It's a relationship that runs in both directions, not in dramatic leaps, but in slow, accumulating effects that gently reroute the path of the species. In the past, the future arrived mostly as a product of natural conditions, changing climates, migrating herds, shifting landscapes. Humans adjusted to these forces with bodies and instincts shaped by millions of years of evolution. Now, the future arrives as a product of cities, technologies, networks, and information systems. People move through environments designed intentionally or unintentionally by previous generations. Instead of adapting physically to the world, humans adjust mentally and socially to the structures they've created. The future comes from inventions as much as from nature, and that blend produces a kind of evolution that feels more like learning and reconfiguration than biological change. One way this becomes apparent is through the environments people inhabit. Tall buildings, artificial lighting, paved roads, heating systems, and digital communication networks create surroundings that didn't exist for almost all of human history. These environments shift the expectations placed on individuals. Someone living in a dense city faces different challenges than someone in a nomadic group. Noise patterns, social density, air quality, and technology use all influence daily behavior. But these influences do not leave clear biological marks. Instead, they reshape habits, preferences, stress responses, and interactions. Over time, widespread habits can gently influence genetics in slow, diffuse ways, but the cultural layer is always the first to respond. Another way the future humans built reshapes them is through information. People now move through a world saturated with knowledge, opinions, data, and constant communication. The brain evolved for environments where information arrives slowly, often tied to face-to-face exchanges, seasonal patterns, and direct sensory experiences. Now information arrives continuously, from sources scattered across the globe. This abundance influences attention, memory, and even emotional responses. But again, the shift happens culturally rather than biologically. People learn new ways of filtering information, adapting through behavior rather than through evolution. Technology plays a significant role in shaping the future humans must navigate. Tools that once expanded physical capabilities now restructure entire lifestyles. Smartphones, computers, robots, transportation networks, and automated systems create conditions that evolution never prepared humans for. These technologies influence everything from work rhythms to sleep schedules, from communication patterns to emotional expectations. And because technology can change rapidly within a single generation, evolution struggles to respond in meaningful ways. The adaptations that arise are behavioral, social, and cognitive rather than physical. People learn to live with the world they create long before their biology has any chance to catch up. Yet these cultural and technological landscapes do more than shape behavior. They also generate new types of pressures, soft, subtle, and often long-term. For example, certain skills become more valuable in modern environments. Adaptability, problem-solving, digital literacy, and emotional resilience influence success more than physical traits once central to survival. While these qualities don't directly alter genes within a few generations, they can influence which families and communities thrive over time. Patterns form around education, opportunity, and social support. But because these pressures are not tied to strict biological survival, evolution doesn't produce sharp, rapid changes. Instead, the drift continues, gently guided by cultural expectations that shift far more quickly than genetic traits can. Even decisions about where people live create new influences. Urban environments expose individuals to different sensory patterns, stress levels, pollutants, and social dynamics than rural or wilderness environments. These differences shape long-term health outcomes. They affect sleep, cognitive performance, and social structures. But because individuals can move freely or adjust their surroundings through technology, these pressures do not solidify into strong evolutionary forces. They remain part of the drift, subtle nudges rather than strict pathways. Climate change adds another layer of complexity. For many species, rapid environmental change triggers intense evolutionary pressure. But for humans, the response involves technology, policy, innovation, and cultural shifts long before any biological shift can take place. Rising temperatures lead to new building standards, new energy systems, new agricultural techniques, and new global strategies. These responses reduce the direct environmental pressure that would otherwise guide evolution. Humans adapt the world faster than the world forces humans to adapt biologically. Yet the altered environment still shapes daily life through changes in weather patterns, resource availability, and migration. These influences shape human behavior and future decisions even if they don't reshape genetics quickly. Another force shaping the future is the way humans connect with one another. Global communication networks allow people to interact across vast distances in ways earlier generations never experienced. Social norms spread quickly, innovations move across continents in months, ideas shift expectations within a few years. These rapid cultural changes create environments that guide human development in non-biological ways. Children grow up learning skills their grandparents never imagined. Adults adjust to new technologies repeatedly throughout their lives. Evolution can't track these changes. Culture handles them before biology has the chance to respond. But even though culture and technology guide adaptation far more strongly than evolution, they also open new pathways for subtle evolutionary shifts. For instance, exposure to artificial lighting may influence sleep-related genes over many centuries if certain patterns persist. Changes in diet could shape metabolic traits very slowly if consistent habits remain. Differences in family size across cultures might eventually influence genetic distributions. But these changes take place across immense spans of time, and their direction is uncertain because cultural patterns change too quickly to anchor stable selective pressures. The future shaped by humans is too fluid for evolution to grab onto firmly. There is also the question of how human-made environments influence emotional development. The emotional system evolved to manage threats, relationships, and group dynamics in small communities. Now it operates within vast social networks, global communication platforms, and complex economic systems. These new conditions reshape emotional experiences, stress responses, and interpersonal expectations. People adapt through coping strategies, therapy, education, and cultural practices. But again, these adaptations do not come from genetic change. They come from flexible minds navigating unfamiliar conditions. The future humans are building creates emotional landscapes evolution never prepared them for, yet culture provides the means to navigate them. Another influence comes from artificial intelligence and automation. As these systems take on tasks once performed by humans, they reshape which skills hold value. Problem solving, creativity, emotional insight, and adaptability become more important than physical labour. These shifts don't guide evolution in strong ways, but they do shape cultural expectations. Children are raised to navigate digital environments, learn technological skills, and adapt to fast-changing systems. Evolution remains in the background, watching a world change too quickly for genes to anchor themselves to any consistent pattern. Even perceptions of health and longevity shift the relationship between humanity and its future. Medical technology extends life, prevents early death, manages chronic conditions, and reduces mortality in ways that alter reproductive patterns. As lifespans increase and health conditions become manageable rather than fatal, the connection between biology and survival weakens even more. This leads to a population where genetic variation remains broad because fewer traits are filtered out. The future humans shaped, one that protects life and reduces suffering, creates conditions where evolution drifts rather than races. The future also shapes humans through choices about work, leisure, learning, and socialization. Work environments influence posture, physical activity levels, and stress. Leisure activities shape motor skills, attention patterns, and social bonding. Educational systems influence problem-solving styles and cognitive development. None of these forces reshape genes quickly, but they mold the behaviors and experiences of millions. Culture continues evolving around these shared experiences, adjusting itself to new tools and expectations. The future, in this sense, is a landscape continually rewritten by human decisions, and those decisions create the world people must learn to function within. As much as humans try to predict their future, the unpredictable often emerges through the very systems they designed. Innovations produce unintended consequences. Cultural shifts lead to new dilemmas. Technology reshapes expectations faster than societies can adjust. These forces influence human behavior in countless ways. But because they move so quickly, they rarely stabilize into steady evolutionary pressures. Biological evolution responds slowly, requiring consistent conditions across many generations. Culture and technology create environments that transform every few decades. The gap between these timescales ensures that evolution remains gentle, while cultural change races ahead. Yet this doesn't mean humans have escaped evolution entirely. Small genetic adjustments continue, some tied to immunity, some tied to diet, some tied to regional conditions. But they occur quietly, in the background, overshadowed by faster, more visible changes happening in society and technology. The future shaped by humans creates room for biological drift, not dramatic leaps. It creates a world where culture does most of the adapting and genes simply follow at a distance. Looking forward, the same dynamic continues. Humans will keep reshaping their surroundings, and those surroundings will keep influencing human development. New technologies will alter behavior. New cultural norms will adjust expectations. New challenges will arise, met first through innovation rather than through biology. Evolution won't disappear. It will continue drifting, adjusting slowly in whatever direction long-term pressures gently nudge it. It's interesting to imagine that even when one pathway becomes quiet, another sometimes begins forming in places no one expects. Evolution has never been a rigid process. It bends, adapts, shifts, and reroutes itself depending on the conditions around a species. When the pressures that once guided human biology faded, it didn't mean evolution had reached its endpoint. It meant the old path had become less relevant, and quietly, other paths began to emerge, not necessarily biological in the traditional sense, but still guiding how humans change across generations. These paths aren't as straightforward as adaptations formed by climate, predators, or scarcity. They unfold within the environments humans create, the decisions they make, and the systems they build. In this sense, evolution doesn't disappear. It simply moves into new territory. One way to see this new territory is by looking at how humans respond to challenges that didn't exist for most of their history. Early humans never encountered digital environments, global networks, dense urban living, constant information flow, or artificial light cycles. Yet modern humans navigate these conditions daily. The changes required to function within these systems happen through behavior, learning, and cultural adaptation rather than genetic evolution. But over long periods, persistent patterns can influence traits at the biological level. For example, if certain lifestyles consistently shape health and cognition across many generations, subtle genetic shifts may eventually appear. These shifts won't look like the dramatic changes of the past. They will resemble refinements that accompany how humans use their tools, structure their environments, and organize their societies. A clear example involves stress. The stress of early humans often came from immediate physical dangers. The stress of modern humans frequently comes from long-term pressures, workload, social expectations, digital communication demands, financial concerns. The human stress system wasn't designed for chronic activation, yet it now functions within a world that triggers it continuously. Cultural adaptations help manage this. Mindfulness practices, therapy, community support, and structured routines. But these tools don't remove the biological impact entirely. Over many generations, if certain groups develop consistent patterns in stress resilience or emotional regulation, genetic drift may begin to follow those patterns. Evolution in this context becomes tied to how people experience modern life, not how they survived ancient landscapes. Another area where new evolutionary paths might emerge involves how humans interact with technology. For millions of years, the body evolved to handle natural movements: walking, climbing, lifting, and running. Today, many people spend most of their time interacting with screens, keyboards, and digital interfaces. While culture does most of the adapting here, through ergonomics, education, and lifestyle adjustments, long-term exposure could eventually influence certain traits. For example, visual processing in the brain could shift gradually if generations continue spending significant time focusing on close-range digital information. But these shifts would not resemble the rapid changes seen in early human evolution. They would be slow, subtle, and influenced more by persistent habits than by survival necessity. There's also the possibility that new environmental pressures will shape humans biologically, but in ways entirely unlike the past. For example, climate change may introduce challenges humanity has never encountered at this scale. Rising temperatures, altered ecosystems, shifting disease patterns, and changing food availability could create selective pressures that unfold over thousands of years. However, because humans respond with technology, policy, and cultural adaptation, biological evolution will only respond to the parts that remain unaddressed. If humans use technology to stabilize environments, evolution may remain in drift. If new pressures persist long enough and resist cultural solutions, evolution may begin to follow them gently. The outcome depends on how stable these pressures become and how effectively humans solve them through innovation. Reproductive choices offer another route for evolution to find alternative paths. In earlier eras, who reproduced was heavily influenced by physical traits. Now, reproduction is shaped by personal decisions, education, lifestyle, economic factors, cultural norms, and individual preferences. These choices influence which genetic traits become more common over time, but the patterns are complex because cultural preferences shift quickly. Evolution usually needs long-term consistency. If certain traits correlate with reproductive patterns for many generations, they may slowly influence the gene pool. But because reproductive decisions remain fluid and unpredictable, evolution follows these patterns loosely rather than decisively. This creates a pathway where evolution reacts to culture rather than ecology. And because culture changes so fast, the biological effects remain modest. Another emerging path involves exposure to synthetic chemicals, pollutants, and altered food systems. These environmental changes can affect human biology in subtle ways. Over many generations, consistent exposure might create selective pressures related to toxin resilience, metabolic efficiency, or immune response. Again, these pressures will not mirror the ones early humans faced. They will reflect the complexity of modern environments, rather than the simplicity of survival in the wild. Cultural and technological solutions often reduce the severity of these pressures, making biological adaptation slow. But the pressures still exist, and over long periods, they may guide genetic drift in directions focused on modern challenges. Urbanization introduces another potential evolutionary pathway. More than half of the world's population now lives in cities, environments that differ dramatically from ancestral landscapes. Urban life includes dense populations, altered sensory experiences, higher exposure to artificial sounds and lights, and different patterns of movement and social interaction. These conditions influence behavior, stress responses, cognitive patterns, and even disease exposure. While cultural solutions help individuals adapt, long-term exposure across generations may begin to shape biological responses as well. Not through dramatic changes, but through subtle adjustments in gene frequencies related to immunity, stress tolerance, or certain neurological traits. Evolution in this context drifts toward traits that quietly support functioning in dense, artificial environments. Global integration also shapes new pathways for evolution. As populations mix, gene pools broaden. This reduces the influence of local adaptations but increases the range of possible trait combinations. New genetic interactions emerge, some neutral, some beneficial, some irrelevant. This wide mixture creates opportunities for evolution, but without strong selective pressure, most changes remain in the realm of drift. However, if certain combined traits consistently support health or resilience in modern environments, they may slowly become more common. This process would unfold gradually, shaped by the stability of cultural patterns rather than the strict demands of the natural world. Artificial intelligence adds yet another layer. As people rely increasingly on automated tools for navigation, memory, problem-solving, and decision-making, certain cognitive tasks may no longer require the same level of biological refinement. If this reliance becomes long-term and widespread, traits related to memory or spatial reasoning could drift without strong selection. Meanwhile, traits associated with adaptability, emotional intelligence, or creativity may become indirectly favoured through cultural systems. This doesn't produce rapid genetic evolution, but it creates a new landscape where cultural demands subtly influence which traits matter. Evolution follows patterns of importance rather than patterns of survival. Medicine continues to expand these alternative paths. As genetic therapies develop, the idea of evolution may shift from a natural process to a guided one. Even though this possibility remains speculative in many ways, early stages of genetic technology already influence how humans think about biology. Medical tools that correct certain genetic conditions prevent those conditions from acting as selective pressures. If these tools become widespread, they could stabilize trait distributions in ways that natural selection cannot. Evolution then finds a new path, one shaped not by the environment, but by deliberate human intervention. It becomes a process guided by values, goals, and scientific advancements, rather than by strict survival outcomes. All of these new pathways share one defining feature: they operate slowly, gently, and indirectly. They do not push humans toward dramatic physical changes. Instead, they create subtle influences that, over long stretches of time, may reshape the species in ways impossible to predict now. Evolution becomes a background process that gets nudged by cultural and technological developments rather than forced by nature. This means the human future is not shaped solely by biology. It is shaped by the interplay between biology, culture, and technology, each influencing the others in a continuous loop. But the idea of evolution finding another path also involves possibilities beyond genetics. Human change now happens culturally, cognitively, technologically, and socially. People modify their environment, their communication, their learning, their behaviours, and their problem-solving methods far more rapidly than their DNA can follow. These forms of change are evolutionary in their own way, not biological evolution, but evolution of systems, ideas, and capabilities. They alter the human experience even if they don't alter the genome. They determine how the species adapts to challenges, relates to one another, and navigates the world they build. As these alternative forms of evolution expand, they create a situation where the boundaries of change become fluid. Traits that matter for success or well-being can shift rapidly. Cultural values shape behaviour. Technological innovations reshape abilities. Social structures redefine expectations. Each of these influences creates conditions evolution must navigate, but none of them impose strict biological requirements. Instead, they create a network of subtle pathways through which evolution drifts. Over many generations, the cumulative effects may produce new patterns, but they will not resemble the rapid, environment-driven adaptations of the past. It's also possible that some future conditions will reintroduce stronger evolutionary pressures. If long-term environmental changes persist, such as heat, altered ecosystems, or new disease patterns, biology may eventually begin adapting again. But even then, culture and technology will mediate the severity of these pressures. The result would likely be a blend of drift and adaptation, shaped by both natural conditions and human responses. Evolution finding another path does not imply a grand transformation waiting just beyond the horizon. It suggests that change continues, but through routes that reflect the complexity of modern life. These routes emerge from the world humans built and the ways they navigate it. Some changes may remain purely cultural, others may drift into biological patterns slowly over generations, and future conditions may reveal pressures that haven't yet taken shape. What remains constant is that evolution doesn't end. It shifts direction when the world changes. There's something grounding about pausing for a moment and looking at the human story not as a sequence of breakthroughs, or as a struggle against nature, or as a march towards some predetermined destination, but simply as a long line of lives connected by choices, challenges, and small acts of adaptation. When stepping back far enough, the noise of progress and the weight of scientific detail soften into a wider perspective, one where the species can be seen as a participant in a vast, unfolding narrative rather than the central character of it. Reflection like this doesn't aim to solve anything. It invites a quiet sense of awareness, a chance to see where humans have come from and where they might be heading, not through certainty but through understanding. People often think of humanity as separate from the natural world because of the structures they build, the technologies they use, and the ways they modify their surroundings. Yet human life is still deeply rooted in the same processes that shaped every organism on Earth. The difference is that humans have learned to step between worlds, the biological and the cultural, the instinctive and the intellectual. This ability to move fluidly across different kinds of environments makes it easy to overlook the biological foundation that still underlies everything. Even though the pressures that once guided evolution have faded, the body carries reminders of those ancient paths. Muscles, bones, senses, emotions, and instincts still echo. A time when the world was governed by dangers that no longer define daily life. Reflecting on this dual identity, creature of nature, creator of culture, adds depth to the human story. People have become architects of environments different from anything evolution prepared them for. They live inside structures built by imagination, supported by technologies capable of altering the conditions of life in ways no other species has experienced. And yet, as sophisticated as these systems become, they remain anchored to the same fundamentally biological roots that shaped their ancestors. The ability to imagine, create, analyze, and invent emerged from neural structures formed under the quiet guidance of natural selection. The entire framework of culture and technology rests on biological capacities that evolved long before writing, agriculture, or electricity existed. Acknowledging this continuity does not diminish the uniqueness of human accomplishments. It adds a sense of scale. Tools, cities, medicines, and networks did not appear out of nowhere. They were built step by minds shaped across millions of years. Every innovation traces back to earlier abilities, cooperation, communication, memory, curiosity, traits that helped early humans survive and now help modern humans transform their world. When people consider themselves separate from evolution, they miss the deeper thread connecting every stage of their development. Even today, with culture and technology driving most forms of adaptation, the biological part of the story still quietly supports the rest. A reflection on the human story also brings attention to how much change has occurred in such a short span. Most of human history unfolded in small groups that depended on the land, the weather, and each other for survival. For tens of thousands of years, daily life remained relatively stable. Then, within a brief moment compared to the span of evolutionary time, everything accelerated. Agriculture, cities, writing, trade, science, industry, and digital tools emerged in a rapid sequence that reshaped the world completely. This pace leaves very little time for evolution to act. Instead of adapting biologically, humans adapted culturally. Instead of changing their bodies, they changed their environments. This shift redefined the role of evolution in the human story, turning biology into a quiet background process while culture raced ahead. Yet, despite this shift, humans continue to feel the influence of older traits in everyday life. Emotions that once protected early ancestors still shape reactions today. Fear, caution, group loyalty, curiosity, and empathy all come from ancient needs. Modern life challenges these responses because many no longer match the world they were built for. But rather than disappearing, these instincts coexist with cultural expectations, creating a layered experience where the old and the new overlap constantly. Reflecting on this mixture provides insight into why life sometimes feels complicated. People aren't maladapted. They are navigating a world built faster than their biology can respond, relying on ancient tools in modern settings. This mix of old and new also shapes how humans view their future. Some look forward and imagine biological enhancement, genetic engineering, and accelerated evolution through technological means. Others focus on cultural growth, envisioning societies that become more cooperative, more stable, or more interconnected. Regardless of the direction, the foundation for all future paths remains the same: a species shaped by ancient processes, living in a world largely shaped by itself. The tension between these two forces, biological drift and cultural acceleration, defines much of the human story. It influences how people understand themselves and how they imagine the generations that will follow. A quiet reflection also brings attention to how deeply interwoven human lives have become. For most of human history, communities were isolated, separate, shaped by local conditions and local challenges. Today, the lives of billions connect through technology, travel, communication, and shared global systems. These connections influence everything from culture to behavior to opportunity. They create patterns that drift across continents, influencing not just individuals but entire populations. This integration means that no single group experiences evolution or cultural change alone. The human story becomes a collective one, where ideas, challenges, and solutions spread across the globe. Even with this connectivity, individual lives maintain a personal rhythm. Each person experiences the world differently, shaped by circumstances, choices, environments, and relationships. The human story consists not just of large-scale trends, but also of countless individual moments, quiet decisions, small interactions, flashes of insight, brief struggles, and moments of peace. These experiences do not alter evolution directly, but they influence culture, and through culture, they influence how future generations understand themselves and the world. In this sense, every life contributes to the larger narrative, even if those contributions are subtle. A reflective look at human development also highlights how uncertain the future remains. The past offers clues, the present offers patterns, but the interplay between culture, technology, and biology makes predictions difficult. People have built a world that changes itself constantly. Innovations trigger new social patterns reshape values, values influence decisions that alter the world again. This feedback loop creates complexity that even experts struggle to interpret fully. Yet within this uncertainty lies opportunity. Humans have the ability not only to adapt, but to choose how they adapt. They shape the conditions that shape them. But reflection doesn't require predicting the future. It simply asks for awareness, an understanding of how humans arrived here and what that journey reveals about their place in the world. It invites recognition that the species carries ancient strengths into modern settings, sometimes gracefully, sometimes awkwardly. It suggests that the lack of strong evolutionary pressure is not a sign of stagnation, but evidence of a species that created its own stability. It reminds people that even though evolution no longer drives them as it once did, the story is still unfolding. The path may be quieter, slower, and less visible, but it continues. A quiet reflection also brings attention to the humility embedded in the human story. For all the tools, advancements, and achievements, humans remain part of a broader natural system, one that extends far beyond their influence. The Earth continues changing. Other species continue adapting. Ecosystems adjust to new pressures. The planet moves through cycles that existed long before humanity and will continue long after. Recognizing this larger context doesn't diminish human significance. It adds depth. It reveals that the species is both extraordinary in its abilities and ordinary in its origins, both creators of their world and shaped by forces beyond their control. Understanding this dual relationship can create a sense of calm. It reminds people that their place in the human story doesn't require grand accomplishments. Participation alone connects them to millions of years of ancestry and thousands of years of culture. Every generation continues the narrative simply by living, learning, and passing on knowledge. The story doesn't belong to any single individual, but every individual contributes to it. This perspective brings gentleness to the idea of progress. Instead of racing toward a specific destination, humanity moves through an unfolding sequence of experiences shaped by choices, circumstances, and the environments people build. Reflecting on this story also highlights the value of curiosity. Curiosity motivated early humans to explore landscapes, learn about plants and animals, observe the sky, and communicate in increasingly complex ways. That same curiosity now drives scientific discovery, technological innovation, artistic expression, and philosophical questions. It forms a thread linking the earliest ancestors to the present. Curiosity allows humans to understand themselves more clearly, to look inward as well as outward, to recognize where they fit in a story far larger than any single life. And in this reflective space, another thought emerges. Even if evolution no longer races, humanity continues to change in ways that matter. Culture evolves, values shift, understanding deepens. The tools people create influence their experiences, their relationships, and their perceptions. These changes shape the internal landscape of human life, even if the external biological traits remain largely the same. Evolution once changed the body to match the world. Now humans change their world to match the body, the mind, and the needs of society. Considering all of this, it becomes clear that the human story is neither finished nor stalled. It is simply moving at a different rhythm than it once did, a quieter one, a more deliberate one, a rhythm shaped by choices rather than necessity, by knowledge rather than instinct, by intention rather than pressure. This shift allows the species to step back and understand itself in a way earlier humans never could. Reflection itself becomes part of the story, an ability made possible by the long path of evolution but directed by culture.